So problem number one asks, what's the probability of selecting a red marble or a blue marble? And really the key is to realize that when they use the word or, that means add the probabilities of each, okay? Add the probabilities. So what would that look like in this case? Well, we know that the probability of selecting a red marble looks like it's 5/19. So simple as that. And then the probability of selecting a blue marble is 4/19. And it really is just as straightforward as simply adding these. The probability of selecting a red or blue marble is going to be 5/19 plus 4/19. Obviously, we're going to preserve the denominator here. We have the common denominator, and then we're going to have 9/19. All right, and that, of course, is answer choice B. Now, for those of you who could perhaps benefit from perhaps a little bit more of a visual, imagine you have a box, all right, and we got these dotted lines here, and there's 19 marbles in there. And essentially the lay of the land is right here, where, clearly 5 out of 19 is the probability of picking a red marble, and 4/19 is the probability of picking a blue marble. And you kind of see here how it would be if you want to figure out the probability of picking either red or blue. Well, there's 9 of those in total, so that's going to be 9/19. All right. For those of you who are wondering what's up with the fractions, it's definitely also worth noting that probability is going to be desired over possible. So the number of possibilities goes down below. Well, there's 19 possibilities, and the number of desired, meaning what specifically are you sort of analyzing, what specifically are you looking to get? Well, that would be 9 of these. And that turns out to be the answer. And the bottom line, one way or the other, the answer to this problem is B. Problem number two asks, what is the probability that a student selected at random from the class on Thursday is in group 4? Well, first of all, probability is desired over possible. And the word possible means how many possible things can happen, or how many possible items are you choosing from, or how many possible students are there to analyze in the first place. And desired means, what is the smaller subset that you're focusing on. Now, again, they said, what is the probability that a student selected at random from the class on Thursday is in group 4? Well, now we want to find out, the probability related to group 4. Well, we can clearly see there are 2 students in group 4. So already that squares away the desire. There are 2 students in group 4 because that's what we're analyzing. And now the only thing left to do is figure out, okay, well, how many possibilities are there? And in the context of this question, that basically means how many total students are there? Well, that could be actually tricky because, you've got this kind of interesting chart that looks like this. And obviously I didn't fully label this side right here, but these are the key values that really are necessary for the problem. So if we want to find out how many students there are, we can sort of recognize that this means that, this is the amount of students in group 1. That's group 1. So there are 8 students in group 1. So we can kind of add that. It's like 8 students in group 1. And then this one says that there are 12 students in group 2. You can always look at the practice test and just confirm that. So there are 12 students in group 2. This is group 3. There are clearly, looks like there's 6. That's the way that I drew it, just so you know. That's 6. You could always double check. Group 3 has 6 on the practice test, so that's going to be plus 6. As far as group 4 goes, we already actually talked about that. That's going to be plus 2. And then we end up with 2 over, and then all you have to do is add this. 8 plus 12 is 20, 26, 28. I could already see we could probably reduce this. That's going to be 1 over 14. And that is how you do that one. And bottom line, one way or the other, the answer to this problem is G. Number 3 asks, for what value of J is the value of K equal to 40? Okay, so that is fancy, weird, uh, standardized test language for saying or asking when you set K equal to 40, what does J equal? Okay, so let's set K equal to 40. And we're going to be like, okay, 40 equals 7 over 5 J plus 54. Now, obviously, we are solving for this J right here, which means we have to get it by itself, okay? Now, the first thing you're going to want to do to get this J by itself is at least get the term by itself, okay? At least get the term by itself. And then you can proceed from there. So how are we going to get the term itself by itself? Okay, we have 7/5 J. Well, you got to get rid of this 54. So that's going to be subtracting 54 from both sides, because in algebra you have to keep everything balanced on both sides of the equal sign. That, of course, would cancel that, and then we end up with 7/5 J equals 40 minus 54. That's going to be negative 14, which lands us right here. Now, there are sort of different ways of going about this. One thing's for sure, we need to get J by itself. Now, there's an interesting trick of the trade where if you have a fraction coefficient like 7/5, you could actually take care of that right away by multiplying both sides of the equation by the reciprocal. That's my favorite way of doing it, all right? Both sides by the reciprocal. By the way, notice my use of parentheses here, because had I not written parentheses around that negative 14, it might have looked like it was 5/7 minus 14, but by putting the parentheses, it clearly communicates that this is a multiplication situation. So the entire purpose of multiplying both sides by 5/7 in the first place was to cancel the 7s and to cancel these 5s, and that leaves just J. Okay, so we have just J, and then J equals whatever this is. Now, let's keep in mind, negative 14, it's really negative 14 over 1, okay? So the reality is, this is really a fraction. You could think of it, at least. You could think of it as a fraction times another fraction. You could think of it that way, and it's helpful in this case to think of it that way, because as many of you may recall, when you're multiplying fractions, you could do this cross cancellation stuff. That's not cross multiplication. That's a whole different thing. I'm talking about cross cancellation, where this cancels with that. So that's going to turn into a 1. That's going to turn into a 2. But we're not going to forget this negative. There's still a negative in front of there, right? So at the end of the day, we are multiplying these sort of new reduced fractions. It's going to be 5 over 1 times negative 2 over 1. And that turns out to be negative 10. If you have to work that out on your scrap paper and just confirm that, go ahead. But that's going to be J equals negative 10, and therefore the answer is A. Okay, problem number 4 asks, what is the absolute value of 3 minus x when x equals 8? Well, actually, that's pretty straightforward. You just plug in 8 for x, so we're going to have 3 instead of minus x. I'm actually just going to write it right now. I'll write it in parentheses, so it's 8 absolute value. And yeah, they just want to know, what is that? In other words, it's an expression. Just simplify it. Okay. Well, bottom line is I wrote these parentheses just to sort of highlight the fact that I just substituted that 8 in for x. However, in reality, I don't really even need it. So on the next line, I'm going to write just 3 minus 8, because that's what it is, 3 minus 8 inside the absolute value symbol. So 3 minus 8 is clearly negative 5 inside the absolute value symbols. Now, the bottom line is, whenever you have absolute value symbols surrounding a negative number, just know that that turns into a positive version of itself. Okay, so that's just going to be 5. And therefore, the answer is H. Now, let's be very clear. Imagine it was, the absolute value of 8 minus 3. Maybe they're getting sneaky with you like that. Well, that would be the absolute value of positive 5. Well, guess what? That's just 5. Okay, so as long as there's just one number in the absolute value, it just turns out the positive version of itself. And if it's already positive, well, it just remains 5. Okay, problem number 5 asks, letting a positive symbol denote a rise in temperature and a negative symbol denote a drop in temperature, what was the change in temperature from the time Tyrese fell asleep until the time he awoke? Well, clearly, seeing as how the original temperature was 24 degrees Fahrenheit, and then it went all the way down to negative 16 degrees Fahrenheit, we're going to have a negative symbol, okay? Negative symbol. Negative symbol. So we know, in other words, the final answer is going to have a negative symbol. So already we can get rid of answer choice C, D, and E, correct? Because C, D, and E all have that positive symbol. So those are just gone, okay? And that leaves actually answer choice A and B. And I can already tell, maybe you could already tell, it's answer choice A, because answer choice B says negative 8 degrees Fahrenheit, and that's not enough. Okay, that's not enough. From 24 degrees, if we went down 8 degrees, well, that would be 16 degrees Fahrenheit, but that would be positive 16 degrees Fahrenheit. We didn't go from 24 degrees Fahrenheit down to positive 16 degrees Fahrenheit. We went from 24 degrees Fahrenheit all the way down to negative 16 degrees Fahrenheit, which is, I don't know, it's like a big temperature drop. So clearly the answer choice is A, or the correct answer is A. Now, some of you might be wondering, okay, well, what if it wasn't that obvious though? What do you do in a situation where it's not that obvious? Well, if you want to know the difference between, two numbers, you can think of it as the distance between the two numbers. Well, you just take the smaller number, the lesser number, and subtract it from the larger number. Okay, so I'll say that again. If you want the difference between two numbers, in this case, it's a temperature difference, right? So if you want the difference between two values, take the lesser number and subtract it from the greater number. Now, the greater number is 24. And now we're going to subtract the lesser number. And we have to be careful here. What is the lesser number? The lesser number is negative 16. So you have to take that into account. Negative 16, 24 minus the smaller number, the lesser number, which is negative 16. And that turns out to be a plus. That's 24 plus 16. Okay. And that, of course, turns into 40. Okay. However, as we said before, there's going to be a negative symbol in front of the final answer because that represents a temperature drop. This is a symbol, in this case, that lets the reader know that, oh, it's a temperature drop as opposed to a temperature increase. So that means that for this particular problem, we will have to represent the final answer in this nice circle as negative 40. 40 units drop from 24 to negative 16, negative symbol in front of the final answer, indicating to the reader that this is indeed a drop as opposed to an increase. Problem number 6 asks, the total of her payments, including the down payment, was how much more than the car's purchase price? Well, it's good to begin with the end in mind. It's good to sort of think of the big picture. Really what they're saying is, what is the difference between how much she paid? I'll just say how much paid. What is the difference between that and the purchase price? Okay. Now, some of you might be wondering, like, well, shouldn't how much she paid match the purchase price? Like, I don't get that, you know? Well, just remember, there was a purchase price, but then she got a loan. And as many of you understand, loans have interest. So if you need a loan, you're going to end up paying more in the final sort of summation of how much you paid. Okay. So, um, again, seeing as how this problem is asking, uh, how much more did she pay than the actual purchase price? Well, this is going to be a subtraction situation. So in a way, this is a way to model the problem, right? We want to find out how much more is this number than that number. Well, how do you find that? You take this number and subtract this number, and then you have your final answer. So we already know the purchase price. That part's easy. The purchase price was just 5,400, right? Okay. The real question is, okay, well, how much did she pay? Right? How much did she pay? Well, I'm going to keep everything in a box just to kind of stick with the original model. So yeah, how much did she pay? Well, she definitely paid 1,000. So that's going to be 1,000. That was the down payment, right? And then she did 28 payments of 200 each. So that's going to be 1,000 plus 28 payments of 200. Of means multiply. So that's 28 payments times 200. Okay, so that's how much she ended up paying. The down payment plus 28 payments of 200. And then from there, obviously, we could just sort of simplify everything and take it from there, and then we'll have our answer. So this is going to be 6,600 minus 5,400, and that's going to equal 1,200. So therefore, the answer to this problem is G. Now, I kind of just went through that relatively quickly. Quick note on this. We had to multiply 28 times 200 first and then add 1,000 to it. Okay, that's what PEMDAS would have you do because PEMDAS, the whole please excuse my dear Aunt Sally or whatever, that basically says that if you have a situation where, you have the choice to either add something or multiply something, um, well, multiply first. Okay, so you have to multiply that and then add 1,000 to it. Now, for those of you using a calculator, which is allowed, you can use a calculator, especially if it's a graphing calculator. You can kind of plug all this in perfectly into the calculator. Just be very careful, 1,000 plus, and then make sure that this is multiplication right here. And the calculator will do the proper order of operations for you. And it should have given you 6,600 if you tried it. All right, so that's how you do problem number 6. Problem number 7 asks, what is the perimeter in inches of the hexagon? So we have a hexagon here, and we want the perimeter. Now, as many of you recall, the perimeter would be the distance all the way around. So the perimeter is the value you would get when you add all of this, these green markers right there, okay? So that's what we're looking for. And the bottom line is they do say it's a regular hexagon, which means that this little side is the same length as this side. It's the same length as that side, which is the same length as that side and this side. And, it is the case that since all the side lengths are the same, then if you want the perimeter, well, all you have to do is just take one side length and multiply it by 6, and that will give you the final answer. So the perimeter in this case is going to be the side length times 6. Okay, and then we're done. Okay, so once again, we want the perimeter, which is the distance all the way around. We know that all the side lengths are equal, even though the way that I drew it, it's not really drawn to scale, but I think you get the idea. So each side length is equal, and there are 6 of them. So if I want the perimeter, just find one side length, multiply it by 6, and then we're good to go. So let's go on a mission to find this side length because it's kind of close to the other clue that we have right here. And um, the clue is that this sort of radius here is called 4, okay? Now it actually is a radius. It so happens that it's the radius of the larger red circle there. So we have a radius of 4, which means the distance from the center of the hexagon all the way to one of the vertices is 4. And that would also mean that this one is 4. And then it's kind of like, all right, well, how do we know what that is? Well, it turns out that one way of knowing is by at least beginning the process of knowing is to figure out the central angle here. Okay, the central angle. So let's imagine we drew these radii all the way around such that we draw the radius from the center to one of the vertices of the hexagon, to each vertex of the hexagon. And you can kind of clearly see that there are 6 angles formed inside there, okay? And these angles are going to be equal all the way around because this is a regular polygon, and that's one of the features of a regular polygon, okay? So the angle all the way around would be 360, but each of these little angles, each of these smaller angles is going to be 360 divided by however many of these angles you have, okay? So that's going to be 360 divided by 6, which means that this central angle right here is 60 degrees. All right, so how did I get that? Well, all the way around, one full revolution is 360. And if I want this central angle, that's going to be 360 divided by 6. Okay. Okay, so that's 60 degrees. And then it's like, okay, great. But how does that help us find out what this is? Well, it turns out that at the very least, we know that this triangle is isosceles. All right, we're going to look at it real quick. Now, some of you might already have the answer kind of in your head, and you're using like intuition or something to figure out the answer. And it's possible you have good intuition, but we want to make sure that we know for sure what the answer is and why. So what I'm going to do is I'm going to extract this triangle out such that this is here. We'll have the bottom right here, and the top will be yellow, and that's 4. We've already discussed that. That's 4. And then we have this 60 degrees right there. So at the very least, when we kind of take this out and flip it so it looks like that, where the 60 is on top, you have a 4 here and a 4 here. Remember, our goal is to figure out what this is. This is the side that we're trying to find out. And bottom line is this is isosceles because this side length is equal to that side length. So at the very least, we know that the triangle is isosceles in that regard. So therefore, this angle has to equal this angle because in isosceles triangles, the base angles are equal. So I'm going to use this sort of red arc rainbow looking thing to just denote the fact that these 2 angles are equal. And you know what, let's just call this angle x degrees, and we'll call this x degrees too. All right. Well, the bottom line is we know that 60 plus this x equals 180 because the sum of all the interior angles of any triangle equals 180. So that is huge for us to take into account. Therefore, we can set up the equation that says 60 plus x equals 180. That's really going to be 60 plus 2x equals 180. And then if I went through the motions, I would soon discover that x equals 60. So in other words, you know, subtracting 60 from both sides, then dividing by 2 to get the x by itself, that would be x equals 60. So each of these is 60. So I'm actually going to go up here and label that. So each of these is 60. So in other words, all the interior angles are equal to 60. All right, so I'm gonna do that right there. I'm gonna put it right in our amazing triangle. So we have 60 and another 60. Okay, so guess what? You know what that means? A lot of you know. Oh, that means it's an equilateral triangle. There's no question about it. There's an equilateral triangle because equilateral triangles are triangles such that all the interior angles are 60 degrees. And another feature of equilateral triangles is that all the side lengths are the same. All the side lengths are the same. So I think you probably understand what that means. That means that this side length is 4 because that's 4 and that's 4. So 4. Now, do you remember what we said before? If we could just find one side length, well, just multiply it by 6 and then you'd have the answer. Well, guess what? That's what we just did. So the perimeter equals 4 times 6, and that equals 24. And therefore, the answer is E. Problem number 8 asks, what is the floor area of the building in square feet? Well, here's the building. And when it comes to these sort of complex figures, you're going to want to break it down usually. Okay, you're usually going to want to break it down. So we're going to break this down and sort of subdivide it into these smaller things. Now, this rectangle here, all right, let me just make this a little nicer looking or more clear that we are forming a perfect rectangle here. So we have 50 times 22 gives us this area, right? 50 times 22. So that's really 1,100. And now we need this. Now we need the length and the width. Well, we certainly have this length here. It's 22. But then the question is, well, what is this? What is this part right here? What's that? Well, the key to finding that is to take into account that this whole thing is 40. That's clearly a piece of 40. And this is something else, right? And we know that when we add this green part plus the red part, it's going to equal 40, right? Well, we already know the green part. The green part is 22 because of this information. If you take this information and just slide it over, it would be 22. So I'll write 22 in green. 22. So then the question is, well, what is this? Well, that's going to be 40 minus 22, which is 18. Okay, so that's 18. So what we have really with this smaller rectangle is 22 times 18, which is 396. And if we are looking for the floor area, the total area, all you have to do is add, these two smaller sub areas, and then you'll have your answer. So we are looking at 1,100 plus 396, and some of you could probably do this in your head. You could always use a calculator if need be as well, but that will be 1496. And that turns out to be answer choice J. Problem number 9 asks you, which of the following is a type of quadrilateral determined by these vertices? Well, I think it's probably smart, and most of you would have the following instinct, to graph. Okay, graph the points on the test pamphlet, okay, on the diagram itself. So A is -2, 0. So that's going to be right here. We'll label that A. Then we have B, which is 0, 4. So that's going to be right here. Then we have C, which is 5, 5. So that's going to be right here, C. And then we have D, which is 8, 2, which is here. Okay. And you can imagine maybe connecting these. So what we're going to do is go straight off the visual, at least at first. we can see that it's definitely not a kite. Okay, let's just be honest. It's a trapezoid. Okay, it's a trapezoid just based on the visual to save time. Don't worry about proving it. This is so obviously, it's one of two things is obvious. It's either obvious it's trapezoid, or it's obvious that it's not a kite, it's not a parallelogram, it's not a rectangle, it's not a square, right? Let's review what the shapes look like. A kite would look like this. Does that look like this? No. A parallelogram would look like this, usually. That's not taking into account the fact that a rectangle and a square is a parallelogram, but this is the sort of you know, figure that most people associate with a parallelogram, and clearly that's not happening here. Trapezoid looks like this typically, which is of course what we have. Then we have rectangle. Everyone knows what that looks like that. And then of course we have a square. Okay. Now, by the way, let me just add this here for maybe the sort of advanced students. It is the case that a rectangle and a square is a kind of parallelogram. All right. And in my view, the fact that that is true means that B, D, and E should be eliminated right out the gate. Because what if it was a rectangle? Well, you could put answer choice D. Like, what if it looked like a rectangle? Well, you could put answer choice D, but you could have put answer choice B as well, because a rectangle is a parallelogram. It's just a particular kind of parallelogram. So that's kind of an advanced logic approach. But one way or the other, simply based on the visual, you know, trapezoid. So that is answer choice C. Number 10 asks, given that f of x equals 3x plus 7 and g of x equals x squared over 2, what is the value of f of g of 4? Okay, they want to know what is f of g of 4. Now, whenever you're given a composite function like this, and there is a number in here, okay, as opposed to a composite function where there's like an x in there, okay, this is a completely different strategy. So we're not thinking about this. We're thinking about what happens when there's a number in there. Well, the thing you want to do here is move from the inside out. Okay, you're going to move from the inside out. In other words, figure out what this is first and then take it from there. So we're going to find out, well, what is g of 4? What is that? That's the first step. Well, apparently g of x is x squared over 2. And as many of you probably recall, anytime you're doing functions and it's like, oh, g of 4, what's g of 4? Well, that just means replace the x with a 4. So if we want to do g of 4, it's going to be like this. It's going to be like 4 squared over 2. And then we have 16 over 2. And then, of course, that is 8. So we know that g of 4 equals 8. So in other words, anytime I see, at least in this problem, anytime I see a g of 4 somewhere, I could replace it with 8. Well, guess what? There's a g of 4 right here, so we're going to replace it with an 8, because we know that g of 4 equals 8. Why not? So now we have a new mission called, you know, what is f of 8? Okay, what is f of 8? We'll put a question mark. What is f of 8? Well, we know that, you know, f of x, according to the problem, equals 3x, you know, plus 7. But we want to know what f of 8 is. Well, again, you just replace the x's with an 8 this time. So that will be 3 times 8 plus 7. I'll draw a little connecting arrow so that you're clear that we're using this function now and we're replacing x with 8. So we have 3 times 8 plus 7, that's something you could do in your calculator, or you could just use PEMDAS and understand that's 24 plus 7, also known as 31, which is answer choice H. Problem number 11 asks, the solution of which of the following inequalities models the number of hot dogs H Julie can sell per month and make a profit? Well, first of all, it's worth noting that revenue minus expenses equals profit. Now, you could write that down if you want, but you could also realize that, well, it makes total sense. I mean, the amount of money you bring in minus how much it costs for you to do business in the first place, well, that's going to give you a certain amount of money left over, right? So once again, the amount of money you bring in, because people pay you for it, customers pay you a whole bunch of money, and whatever that amount of money is minus how much it costs you to do business in the first place, well, that's going to leave you with money left over called profit, okay? So in my view, this is sort of the best thing to focus on in this case. So just know that whenever you're thinking about profit, whenever you're thinking about, oh, I am imagining what the profit might be of something, just know that that really means this, okay? So this and profit are the same, they equal each other. Okay, so whenever you're thinking about profit, it's always going to be revenue minus expenses. Well, in this case, we want to have a profit, right? So in order to have a profit, it's got to be greater than 0. So the profit has to be greater than 0 in order for there to be a profit, because if it's less than 0, it's not a profit. It's, in fact, you're hemorrhaging money and you need to make changes in your business so that you have a profit. If it equals 0, well, then you're just breaking even, okay? You're just breaking even. But in order for there to be a profit, the profit has to be greater than 0. So I'll actually write R minus E in here. Okay, I could have written P is greater than 0, but for this particular problem that we're about to do, actually is a little bit more helpful to remember, oh, it's just revenue minus expenses. So the revenue minus expenses has to be greater than 0. Okay, so what is the revenue? Okay, I'm going to drop the blue box on the next line, but I think you get the idea. The revenue is the amount of money you take in. Well, if Julie is selling hot dogs for $2 each, and she's selling H hot dogs, well, the revenue is going to be $2 times however many hot dogs she sells, which is H, right? That's the revenue. And then the question is, okay, well, what's the expenses? The expenses are, well, it costs her $200 apparently to, every month to set up all the supplies and, purchase the hot dogs and stuff. So that's going to be 2H minus 200. So that is a way of understanding, okay, what is the revenue, what is the expenses, and then we have revenue minus expenses, and that's going to be, of course, greater than 0 in order for it to be a profit, and that is why answer choice E is the answer. Answer choice D would bring us less than a profit. Answer choice A, it doesn't take into account that the hot dogs are $2 a piece. Answer choice B is another thing that's less than 0, so we're not interested. Answer choice C adds the revenue and the expenses, so that's gone. Problem number 12 asks, what is the slope of the line 3x plus 8y equals 5? All right, so 3x plus 8y equals 5. Well, I think probably the best way for most students to go about this, I'll just cut to the chase, is to turn that into slope-intercept form. Now, as you may recall, slope-intercept form is this whole thing where it's like y equals mx plus b. And the m represents the slope. So in other words, if you could just mess with this thing to get the y by itself, then you could just like look at it and kind of see what the slope is. All right, so if you could force this equation of the line to be in slope-intercept form, it'd be pretty easy to see what the slope is, and then you'd be done. Okay, so the question is, how can we do that? Well, we can start by understanding, okay, the goal is to get y by itself. Well, let's at least get 8y by itself. So therefore, we got to get rid of this 3x. So it's going to be minus 3x minus 3x. And then we end up canceling that. And then we have 8y. I'll keep y in blue because that's the target. And then we have 5 minus 3x. Now, I could write 5 minus 3x, but I'm going to write it as negative 3x plus 5. Now, why am I doing that? Why am I not writing it as 5 minus 3x? Because I could. Well, I'm writing it as negative 3x plus 5 because I want it to kind of look like this, right? I want the x term, the term that has x in it, I want that to come first, and then I want constants to be after that, okay? So I'm forcing this to look a little bit like the slope-intercept form. That way I could clearly see what m is once we're finished. And we're not finished yet. Don't be tempted into being like, oh, the slope is negative 3, and then you would incorrectly answer the problem with answer choice F, and that's wrong. You have to go further. You have to divide both sides by 8 because, again, we are trying to get this blue y by itself, and we got to get rid of this 8 that's right there, and we're about to do that. We cancel these 8s as a result, and then we end up with y equals, okay, this deserves a little bit of focus. We have negative 3x plus 5 all over 8. Now, the truth of the matter is, since these two terms here are being separated by addition, then both of them are getting divided by 8 separately. Okay, now if these two terms, negative 3x and 5, if they were being multiplied, then the 8 would only cancel out with one of the numbers. But since they're being added, both terms are going to be divided by 8. Now, what does that look like? It's going to be negative 3x over 8 plus 5 over 8. Now, as you can tell, we're like really getting close to what this looks like. I mean, it's kind of a weird y-intercept, but whatever, 5/8, that's an actual value, It's not a whole number, but it's a value. It's a constant. There's no variable attached to it, so that's another thing. So it looks like we already definitely have our y-intercept, so that's good news. But unfortunately, the problem is asking for the slope, which is found here somewhere. Well, the bottom line is, negative 3x over 8, that could really be rewritten as negative 3/8 with this sort of x off to the side like that, plus 5/8. And therefore the slope is negative 3 over 8. Now, some of you might just be willing to understand that and be like, okay, or I guess that's just two different ways of writing the same term. And it is. But in case you're unclear about why that is, let's actually go backwards. Let's look at negative 3/8 with this x off to the side. Well, that's really negative 3/8 times x over 1, right? Isn't it? Because there's secretly a 1 underneath that x. So even though I drew the x off to the side, it's really just negative 3/8 times x over 1. And then when you multiply these together, you could write it as negative 3x over 8. Because when you multiply fractions, you just go straight across. So the moral of that story is that this and this are two ways of writing the same expression. You could have x off to the side or the x up top. It really doesn't matter. So anyway, here we are. We have negative 3/8 in front of the x, which means that m, the slope, is negative 3/8, which is exactly why answer choice G is the answer. Okay, so number 13 asks, which of the following xy pairs is the solution for the system of equations x plus 2y equals 2 and negative 2x plus y equals 16? Well, it is going to be a system of equations problem, so let's stack them in the way that systems of equations are typically stacked, which is to put one over the other and also make sure that like is over like. And what I mean by that is, let's just make sure that the x terms are over the x terms and the y term is over the other y term, and then just kind of take it from there. Now, there's a few different ways of solving systems of equations. You could graph both of these and see what the point of intersection is, and that would be the solution, okay? So you could actually use graphing calculator to graph both of these, maybe put it in slope-intercept form, and then just really zoom in and take a look, okay, well, what is that point of intersection? The x-coordinate and the y-coordinate would represent the so-called solution of the two equations. Now, graphing can be a little, I don't know, not the best option, because what if you end up with like a fraction or a decimal value, as with regards to either x or y coordinates? That could be a problem. And even if you look at the answer choices, you do see some decimals in there, because imagine you did graph it and they intersected at some point that was like a decimal. It'd be kind of hard to see exactly what that value was. Okay, think about that. So we are stuck with the algebraic ways of going about this, or we should really use algebra to do this. Now, the good news is a substitution is a prime candidate, because we have an x by itself here. There's no coefficient other than 1. There's secretly an invisible 1. And we have a y coordinate by itself too. So anytime you have either x or y kind of by itself, it's actually a good candidate for the substitution approach. Now, what you want to do with the substitution approach is you just want to pick the equation that has either x by itself or y by itself. Now, in this case, it's both, but we're going to pick one of them. We're going to pick this one, and we're going to solve for x in a sense. We're going to solve in terms of, solve for x in terms of y. And we would do that by subtracting, 2y from both sides. Okay, that would end up becoming negative 2y plus 2. Okay, now in case you're not clear how I move from here to here, imagine just subtracting 2y from both sides of the equal sign. Okay, and then you would have x equals negative 2y plus 2. Maybe you would have thought of it as 2 minus 2y when you subtract 2y from both sides of the equal sign, but sort of my experience leads me to put the variable in front. I'm already foreseeing that's going to be a good idea. So what this means is anytime we see x, we really could write negative 2y plus 2. So I'll say that again. Anytime we see x, we could really put in negative 2y plus 2. Okay, that was very repetitive, but I think it bears repeating. So we're going to have this equation rewritten now as negative 2 times what? Not x, but this, negative 2y plus 2. Okay. And the whole point of the substitution method for solving systems of equations is to make it so that you now only have one variable to deal with, and then you can solve for it and then just kind of take it from there. So instead of writing negative 2x plus y equals 16, it's going to be negative 2 times this whole thing, because that's x, plus y equals 16. So what do we do here? We could distribute that, right? So negative 2 times negative 2y is positive 4y. Negative 2 times positive 2 is negative 4. We still have this plus y hanging out, so don't forget that. A lot of students would forget that, unfortunately. Don't forget that. And then we have this equals 16. Then we can combine these like terms. Obviously, that's going to be 5y minus 4 equals 16. Now we're going to add 4 to both sides, and that's going to give us 5y equals 20. We're now going to divide both sides by 5, and then y, therefore, equals 4. Now, some of you who are used to solving systems of equations with maybe the substitution method in school might feel compelled to now find out what x is, and you totally could. You could plug in 4 for y and find out. You would soon find out that x is equal to looks like it's going to be what's that? Negative 8 plus 2. This could be 6. Negative 6 rather. So you could do that if you want, but if you think about it, this is enough. Why is that enough? Because there's only one answer choice that features the y coordinate of 4, or the y value of 4, and that's answer choice A, and therefore we are done. Problem number 14 asks, 2 towns that are 2 3/4 inches apart on this map are how many actual miles apart? In my opinion, this is best approached with a proportion, and let's put inches over miles. Now I know there's mixed numbers, there's fractions, and it's just a big mess. But as long as you sort of just take the big picture, it's like, all right, a certain amount of inches corresponds with a certain amount of miles, and we'll just take it from there. Okay. Well, the first piece of information they give you is that every 1/4 inch corresponds or represents 16 miles. Okay. And then they're like, oh, two towns that are 2 3/4 inches apart are how many actual miles apart? It's like, I don't know. Miles is the unknown. So look at, I'm setting up a proportion. Okay. So miles is the unknown. Miles is down below. Miles is the unknown. That's what we're trying to figure out. And we're trying to be like, oh, like 2 3/4. Like, what's going on? Okay. 2 3/4 inches. I mean, really, the question is 2 3/4 inches is how many miles? Okay. If it's the case that 1/4 inch corresponds with 16 miles. Well, as many of you know, we could totally cross multiply here. However, mixed numbers, you're going to want to turn that into an improper fraction. Before you start doing calculations and cross multiplying and doing anything like algebraic, just in general, make sure you turn the mixed number into an improper fraction because that's something that you could actually work with. So we are going to basically review how to do that. 2 3/4. What is that as far as an improper fraction? Well, basically, you're going to take the bottom number, multiply it to the big number, and then add the top number. I'll say it again. Take the bottom number, multiply it times the big number, and then add the top number. In fact, I will draw that. Multiply, asterisk for multiply. Add, yay. Okay, that's what we're going to do. And the process that I just described will give you the numerator, and the denominator is going to stay the same. So 4 is the denominator in the mixed number, so 4 is going to remain the denominator. In fact, I'm going to write it down below because I already know it's going to be 4. So 4 times 2 is 8 plus 3 is 11, so that is really 11/4 right there. So what I'm going to do is actually rewrite this whole thing only now with 11/4. Okay, so we have 1/4 over 16 equals 11/4 over x. Now, there is some like simplification that I could do. I'll put these in parentheses to make it clear. This is the numerator here, the ultimate numerator. Same with this. Now, I could simplify this and I could simplify this and kind of tweak these separately. But you know what? I think we can get away at this stage with just cross multiplying, because I'm sure if you're watching this, you're just like, all right, can I just cross multiply the darn thing? Because I know how to do that. So basically, when you cross multiply, it's 1/4 times x. So that's going to be 1/4 x. Okay. We don't know what x is, so we're kind of stuck with that. Whereas this is going to be 16 times 11/4. Okay. 16 times 11/4. We're going to analyze that in a moment. Okay. Now, we're going to analyze it now. Okay. We could absolutely simplify these by doing a cancellation here. Okay. That's what we're going to do. There's actually a couple ways we could solve this at this point. But I'm going to do the textbook way just to avoid confusion. Now, the textbook way, which is the typical way most students are taught, is like, all right, simplify both sides. So we're going to simplify this side right now by turning that into a 4 and turning that into a 1, because that's a cross cancellation. 16/4 is really 4/1. So then we're stuck with 4 times 11, and that's going to be, 44. And then we have 1/4 x equals 44. So that leads to the question of like, well, what do we do now? We're trying to solve for x, right? So, well, it turns out that when you have a fraction coefficient, a really efficient way of solving for x at this point is to multiply both sides by the reciprocal. Because what that does is that cancels everything here, leaving me with just x. And then we end up with 44 times 4/1, which is really 44 times 4, which is really 176. Okay, and that is exactly why answer choice K is the answer. Okay, which of the following matrices is equal to 4 times that matrix? Okay, so this is what they give you. Now, I'm sure there are many of you who are scared of this problem because you're looking at it, you're like, I don't know what a matrix is. This is terrible. What the heck is that thing? Here's the good news. There's a lot to be said about matrices, but for the ACT, you really don't need to know that much. And what they're asking you to do in this problem is like super easy, okay? All you have to do is recognize that, oh, this is a matrix, and this is a number that's on the outside that's being multiplied to the matrix. Well, this number is called a scalar. Anytime you have a number that's on the outside of a matrix that you're about to multiply to the matrix, it's called a scalar. Turns out multiplying by a scalar is super easy. All you have to do is multiply 4 times everything that's inside there. So in other words, the final answer will have some number here, some number here, some number here, some number here, and it's just going to be 4 times whatever was in there, okay? Now, already, the fact that when you multiply a matrix by a scalar, the fact that the sort of dimensions of the matrix stay the same, it's still going to be a 2 by 2 matrix as the final answer. Well, already that means we can eliminate answer choice A and B, because answer choice A has a 1 by 2 matrix. Answer choice B has a 2 by 1 matrix. So those are gone. So it comes down to C, D, and E. Well, let's see what happens. When we multiply 4 times -1, that's -4. Now, the truth is that we could stop, because now we have the answer. It's answer choice E, because answer choice E is the only one that has -4 up in the top left corner. But for the sake of being thorough, let's just find out the rest. So 4 times -1 is obviously -4. 4 times 2, well, 8. There we have 4 times 0, so that's going to be a 0 down there. We're going to have 4 times -4, that's -16. Okay, so that's sort of the full answer, but again, answer choice E. Now, you might be asking yourself, okay, this is a little bit messy. What's up with these underlines? Well, you don't have to write the underlines. I only drew the underlines before just to show you that there are going to be elements inside the matrix in those positions, and that the final answer is indeed going to be a 2 by 2 matrix. All right, but usually the answer will be written the same way that answer choice E presents that matrix. In other words, without underlines. Problem 16 asks, what is the value of tan A in the right triangle ABC below? So here's a triangle. And as many of you know, there is this special acronym called SOHCAHTOA that is going to be helpful here. And basically what that means is the sine of an angle, all right, I'm going to use a theta symbol for the angle. The sine of an angle is always going to be opposite over hypotenuse. The cosine of an angle is always going to be adjacent over the hypotenuse, and the tan of an angle is always going to be the opposite or the adjacent. Now, in this case, the trigonometry functions require us to know that this is the hypotenuse, and these are typically called legs, okay, but this is the hypotenuse. There's always going to just be one hypotenuse, and the hypotenuse is always going to be across from the 90-degree angle. It also happens to be the longest triangle side length when it's a right triangle, okay, and also only right triangles have hypotenuses, okay. So yeah, clearly we're being asked about tangent in this problem, and specifically they're asking for tan of this angle A right here, okay. Well, we know that the tan of any angle is opposite over adjacent, so we know that the tangent of this angle, the tan of this angle, well, that's going to be the opposite over the adjacent. And then the question is, well, what is the opposite? What is the adjacent? Well, the opposite is the side length that's all the way across. So we have this angle A, and then all the way across on the opposite side is 15. So the opposite is 15, and the adjacent is going to be the side length that's connected to or next door to angle A, that's not the hypotenuse. So that's important. This is the hypotenuse. So we're not talking about this. We're talking about this. So adjacent means the side length that's next door or connected to. That's not the hypotenuse. So it's 8 in this case. And that's it. That's all you need for this one. The answer is J. Now, had they asked for sine of theta, had they asked for sine of A, well, that would have been opposite over hypotenuse. So sine of A would have been 15 over 17. Cosine of A would have been adjacent over hypotenuse. So cosine of A would have been 8 over 17. Obviously, the problem did not ask us for any of that. They asked us for tangent, and therefore the answer is J. Problem number 17 asks, at this rate, how many miles will she run in 12 minutes? Well, one thing you could do is you could, first of all, remember that an hour is 60 minutes. And we're really mostly concerned with miles per minute, so miles over minute. And you could set up a proportion. Okay, this is one way of going about it. And the proportion could be such that we know that Tina can travel 8 miles for every how many minutes? Well, 1 hour, right? 8 miles per hour. So it's 8 miles for every 60 minutes. Okay, so you could just immediately put things in terms of minutes, miles, and minutes. It's actually not hard to do. It's 8 miles an hour. Well, that's 8 miles every 60 minutes. And then you could set up the proportion where it's like, okay, how many miles will she run in 12 minutes? Well, X is the miles, the unknown, I should say, is miles. So we're going to put an X up here. And then the amount of minutes we're analyzing in this case is 12. So this is a proportion that you could solve for. Now, one thing you could do that will definitely work is cross multiplying. You could absolutely cross multiply. There's another thing you could do too that's a bit of a shortcut. You might notice that, oh, well, 60 divided by 5 gives us that. So the question is, okay, then clearly, 8 divided by 5 is going to give us this. And what is 8 divided by 5? Well, 8 divided by 5 is just 8 over 5. So X equals 8 over 5. Now, it so happens none of the answer choices reflect that. They try to be pretty sneaky with you by giving you answer choice A that says 5 over 8, but that's not what we're doing. But there are a couple mixed numbers in there. Now, the case is likely that we're going to have a mixed number answer. Now, the truth is that I already know it's D, because if we convert this to a mixed number, well, the denominator of the mixed number is still going to be 5, and answer choice D reflects that. Let's say you aren't comfortable doing things that way. Let's say you would rather be thorough, if for no other reason than to feel totally confident in your answer. So how do you convert an improper fraction into a mixed number? Well, what you do is you treat it like a division problem, because actually it is. And you go back to this old school long division stuff. So how many times does 5 go into 8? Well, it goes into 8 once. And then what do? You go 5 times 1 is 5. And then you subtract 5. And then you have 3. And that's your remainder. So the final answer is going to be 1 and 3/5. Now, let's be clear. The denominator always stays the same. We have this improper fraction, we have this mixed number, the denominator always stays the same. This is the big number. The quotient is the big number. So that ended up being right there. And the remainder is always going to be the numerator. So whatever it takes for you to remember that would be good. It's really quotient, remainder, and the old denominator. That's how it works. Okay, so the answer to this one is D. Problem number 18 asks, what is f of negative 3? Turns out this is a pretty straightforward problem. So we have the original function, f of x equals negative 6x cubed, or squared, I should say, actually. It looks like it's squared, huh? Squared. And then they say, oh, what's f of negative 3? Well, again, straightforward. F of negative 3, all you got to do is really just rewrite the original thing, original function, only instead of x, I'm going to write an empty parentheses. That's a good way to go. Just write empty parentheses at first. And then you're going to put this number in there. I would actually strongly advise writing the empty parentheses first, though, and then focus on, okay, well, what am I going to put in there? And then go ahead and put it in there. I'm actually going to make this green to make it stand out and to make very clear that we are putting that right there. So, PEMDAS, please excuse my dear Aunt Sally order of operations thing, tells us that we should totally apply exponents before multiplying anything. Some of you might be tempted to go ahead and just multiply negative 6 times negative 3, oh, positive 18, and then take it from there. But that's wrong. You want to apply any exponents if possible first. And there is an opportunity to do that. We have negative 3 squared. Now notice how this negative 6 is unaffected by that exponent of 2. So it's not negative 6 being squared, it's just this negative 3, okay? It's actually one more reason for you to use the empty parentheses approach. You know how I wrote empty parentheses instead of x? That really helps you see that the exponent applies only to the negative 3. So the question is, what is negative 3 squared? Well, that's 9, okay? Positive 9, actually. So really, we're going to have negative 6 times what? Positive 9. Okay. I'm going to leave negative 6 out of parentheses. I'll keep the positive 9 in parentheses just because I had it there before. Do I have to do that? Not necessarily. I could have written a little dot here where it's like negative 6 times 9. But I'm going to keep it in parentheses just to sort of show that this is the same number as this situation. So negative 6 times 9, obviously, is negative 54. Hopefully it's obvious. Hopefully your multiplication tables are okay. You do have a calculator, though, if you need one. So the answer to this one is G. Problem number 19 asks, what is the measure of angle ABC? I can already see this is giving us information we don't need, which actually turns out to be good. So obviously this is what we're dealing with. We've got A and C, and we got a B here, and ultimately we're trying to find out what this is. Okay, the green. And also down here we have 132 degrees. Okay, so it turns out this is not going to be hard at all. Okay. It's like they give us this line and this line, but this line right here or segment right here, that's actually like totally unnecessary. I think with this problem, they're trying to bait you into thinking, is it like an exterior angle theorem kind of thing? Is it an alternate interior angle kind of thing? Is it one of those things that has to do with parallel lines? Because it is true that these two lines are parallel. I'll give you that. They are parallel. But it just so happens that you don't need that to know that, because all you need to do is pay attention to this right triangle with the understanding that we are trying to find angle, what is it, ABC. Okay, angle ABC. That's this angle, right? That's this angle. Well, let's focus on this triangle. Some of you may remember there's something called the exterior angle theorem, which I'm briefly going to talk about. Let's temporarily forget this and focus only on this. Imagine this right here is 120. The exterior angle theorem says that if you have an exterior angle on the outside like this, like a triangle is on the floor and there's this angle that's on the outside, 120 is going to be equal to x plus y. So I'll actually write that down. 120 is equal to x plus y. In other words, 120 is equal to the sum of these two, sometimes they call these the remote angles. The remote angles. So the exterior angle equals the sum of the remote angles. Why do they call them remote? Because remote means like far away. Remote control. The whole purpose of a remote control is that you can change the channel from far away, right? So these are the two far away angles. When you add them, you get 120. That's always going to be the case. That's one way of going about it. Now, it turns out you could totally do that with this because 132 is an exterior angle, and that's going to be equal to this one plus that. Now, this we'll call x. Okay, we'll call x. So we could say, oh, 132 equals x plus the other remote angle. Well, that's this. What is that? That's 90, right? And then subtracting 90 from everything gives us 42. And then we're done. The answer is B. Problem number 20 asks, which of the following expressions explains what the calculator will display when any number n is entered? Okay, even though this seems perhaps intimidating because it seems somewhat foreign in the sense that, like, I don't know, I've never done a problem like this, like with a calculator and inputs and whatever. Turns out you probably have done problems like this that feature the XY coordinate plane. Anytime you ever did, like, you know, the whole table thing where there's X and then there's Y, and then maybe you have a line here that's like that, and you kind of list the different X coordinates and different Y coordinates. Anytime you did that, it was actually something similar to what we're about to do. So have no fear, this will make sense in a moment. I think instead of X and Y, we're just going to call it inputs, also known as N. Okay, put N in parentheses. We'll say we're going to put the function here, which, by the way, is going to be where our answer goes. And then we have outputs here. And according to the problem, anytime you put 5 in, you end up getting a 2. Anytime you put in a, was it 15? You end up getting a 6. So really what you could do, I mean, there's a few things you could do, but one thing you could do is you could just test the answer choices, believe it or not. I'm going to say let's test the easy ones first. We have H and J. That looks pretty easy enough. Let's test out n minus 3. Would that work? N minus 3. Would that work? Well, I don't know. Keep in mind, n is the input. So 5 minus 3, yeah, that gives us 2. 5 minus 3, that does give us 2, right? So it checks out there, but the problem with this one is that it doesn't work here, because if we did 15 minus 3, well, that does not give us 6. So that's a problem. So we already know that answer choice H is gone. We also know that answer choice J is gone because we knew that answer choice H was n minus 3. N minus 3 worked for the top row, but didn't work for the bottom row. And if n minus 3 works for the top row, well, n minus 9 is not going to work for the top row. In other words, 5 minus 9 is negative 4, and that's not 2. So that leaves us with the fraction ones, which is kind of annoying. So what we're going to do is test out answer choice F. Answer choice F says 2/5 times the input. Well, the input in this case is 5. Does that give us 2? Well, yes, because these would cancel, leaving us with just 2, and that's 2. Would that work with this one? 2/5 times 15. What happens over there? Well, actually, that would work as well, because if you look here, in the same way that the 5's canceled, well, this 5 is going to turn into a 1. This 15 is going to turn into a 3, and that leaves us with 2 times 3, which is 6. So that actually works. So it turns out that answer choice F, the function 2 over 5 times n, that does work. So I actually would go ahead and use the answer choices test each answer choice, starting with the easy ones so you can rule them out as quickly as possible if need be, and then stumble upon your answer that way. The answer, obviously, as a result of our work, is F. Problem 21 asks, the temperature first fell below 49 degrees Fahrenheit between, which of these answer choices? And in my opinion, probably the smartest way to go about this is to just model it with a picture. And in this case, I'm going to suggest some kind of rectangular shape like this. And getting clear that the starting point is most definitely 8, right? Most definitely 8. And then it goes from 8 to 9 and so on. So we're just going to kind of fill out a few of these real quick. So we have that. That's going to be 9. That's going to be 10, 11, 12. This one's going to end up being 1 o'clock. And then we have 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock. I think that should probably do it. So then we have 8 to 9 to 10 to 11 to 12. And then it's 1. And then it's 2, 3, 4, 5. And we'll do a little dot, dot, dot. So on the bottom, I'm going to write the temperature. So it started at 49 degrees, and then it goes up 1/2 of a degree every hour. So from 8 to 9, it goes from 49 degrees to, we'll just call it 49.5 degrees. And then from, 9 to 10, it goes up to 50 degrees. And then it goes up 1/2 from there, so it's going to be 50.5. And then from there it goes up another 1/2, all the way up to 51 degrees. Now, according to the problem, at noon, that's when it begins to actually drop. And when it does drop, it drops 1 degree per hour. Okay, 1 degree per hour. So let's kind of map this out a little bit. It goes down to 50 from 12 to 1. Okay, so just remember at 12 noon, like in that moment, it was 51 degrees in that moment. And just to maybe even sort of demonstrate it more clearly, that's when the cold front went through. When it was at 51 degrees, that's when it started going down. So it goes from 50 to 49. So literally at 2 o'clock, it's 49. Then it goes from 49 down to 48, and then 47, 46, and so on. And the problem is specifically asking the temperature first fell below 49 between which two, times. And that would be this moment right here. Okay, it dipped below 49. So therefore it dipped below 49 between 2 o'clock and 3 o'clock. And therefore the answer is C. Problem number 22 asks, which of the following could not have been the number of points he scored on the final exam? Well, it's really important to be clear on their initial description, where they basically say the letter grades in Hugo's math class are based on the percent of total possible points on the 4-unit exams and the final exam. So probably smart to get clear on what are the total possible number of points that you could hypothetically get, in a perfect world, right? If you got a perfect score on everything. Well, it's 4 exams, each worth, 100 points. Okay. And then you have this one final exam that is itself worth 200 points. So obviously we could just add this to get the total number of possible points. We could have also multiplied this 4 times 100 plus 200. But one way or the other, this is going to be 400 plus 200. And therefore we're looking at 600 total possible points. Okay. Now, in my opinion, the smartest way to go about this problem is to really just recognize the fact that Hugo apparently got a B, which means that he got somewhere in the range of 89% of this and 80%. Okay. So he is somewhere, the total amount of points that he did get are somewhere between these two extremes because he got a B. All right. According to the chart, that's what a B is. So he scored somewhere between 80% of this and 89% of this. In my opinion, the smartest way to go about this is to just figure out, well, what are those parameters in terms of the total points that he scored? In other words, let's find out, okay, what is 80% of this and what is 89% of this? And then we'll have the range of points that we know that Hugo scored in between. So when investigating percentages, you could ask yourself, okay, well, what is 80% of 600? And you could think of that as a written question, what is 80% of 100? Now, there's a lot of different, or 600, I should say. Sorry, I know I said 100 before, but it's 600. So we want to find what is 80% of 600. Well, you could immediately translate that into an algebra equation. So the word what is x, the word is means equals. 80% should be converted into a decimal, so that becomes 0.8. Interestingly enough, the word of means multiply. So we're going to put a little asterisk there just to make sure that it's differentiated from the x. And then we're going to put 600. 600 just remains itself. Okay. And this is clearly very straightforward. All you have to do is multiply 0.8 times 600, and that becomes 480. Okay, so then we could do a similar thing where we now ask what is 89% of 600 possible points. That way we could have that top parameter, and we're going to do the exact same thing. I'll write it here. What is 89% of 600? So once again, the word what is x, the word is equals. The percentage, 89%, converts to a decimal, that's 0.89. The word of is multiplication, and then we have 600. And then you could just use your calculator to multiply 0.89 times 600. And that turns out to be 534. Okay, so we have the parameters. If Hugo got a B, that means that he attained 80%, anywhere in between 80% and 89% of 600 possible points. So therefore, it's safe to say that Hugo scored between 480 points and 534 points. And at this point, we can add up the amount of points he already achieved from those 4 unit tests. And that's going to be 82 plus 88 plus 91 plus 83, and that equals 344. So at this point, what I would do is I would just focus on the amount of points that we know Hugo has, which is 344, and then keep adding answer choices. And just see which answer choices, when you add it to the 344 points that Hugo already achieved, would land you in this sort of interval, and which answer choice, there should only be one answer choice that lands you outside of this interval because this empty space here represents the score that Hugo got on the final exam, okay? And we know the total points need to be no less than 480 and no more than 534. So looking at answer choice F, that's 136. And by the way, I think it's smart to look at the extremes, by the way. Okay, this is actually important. Notice how answer choice F says 136, and that's the smallest option. Like that's the number that's the least, you know, least number of the list of possible answer choices, whereas answer choice K has 196, and that's the greatest number in the list of choices. So you're going to want to mess with the extremes because you know that it has to be one of the extremes because it's either a number that's too small, in which case it lands us below 480, or it has to be a number that's too large, in which case it lands us above 534. So really, first we're going to test 136. So the question is, well, what is 344 plus 136? I'm going to do that right now. Plus 136. That actually is 480. So that lands us right on within the parameter, okay? Barely. So Hugo actually barely got a B, okay? Because if it's the case that Hugo got a 136 in the final, at this point I know the answer is K because, again, we're investigating only the extremes. We just investigated the least number in the list of options, and the least number landed us within the appropriate parameters. And the question is asking which of the following could not have been the number of points he scored on the final exam. Well, clearly he could have scored 136 because that would have landed in within the interval. For those of you who would like the satisfaction of sort of proving that answer choice K is the answer, well, all you have to do is add 196, which is answer choice K, to 344, and that would give you 540. Okay, if you add 344 plus 196, which is answer choice K, that would have landed you at 540, which is too large. 540 would be over here. It's outside of the interval. Therefore, answer choice K is the answer because there's one thing you know for sure, Hugo did not get 196 on his final exam. Okay, problem number 23 asks, when all the pins are set up, which of the following values is closest to the area in square inches that is covered by the bases of the pins? Well, there's 10 pins. So if we could just find the area covered by the base of one pin, then we could clearly just multiply that by 10. So it's going to be 10, the final answer is going to be 10 times the, I'll just call it the pin base area. So clearly this is going to lead to the answer. Okay, now obviously when you begin with the end in mind like this, which is the big picture, this is the big picture of what we need to do. It sort of highlights what you need to do next. And what you need to do next is find the pin base area of one single pin. Well, the base is circular, so let's remind ourselves that the area of a circle is pi times radius squared. So we could find the area of one of these, pin bases if we just knew the radius. So the question is, what's the radius of each pin base? Well, apparently, the diameter of each pin at its base is 2.25, okay? And as many of you probably remember, the radius is going to be half that. So if the diameter is 2.25, we need to ask ourselves, well, what is that going to be? And that's the radius, okay? So 2.25 divided by 2 is 1.125. 1.125. So it's kind of a crazy looking number with the decimals and everything. But what we're going to do now is find the area of one pin base. So I'll write A equals pi times the radius squared. Now we know the radius is 1.125. and we will be squaring that. And I would suggest using the calculator for all of this stuff because in this problem, they ask when all of the pins are set up, which of the following values is closest to the area, meaning it's going to be okay to round things for this particular problem. And the pi symbol, as many of you know, can be converted to its famous estimate, 3.14. So I would suggest doing all of this in the calculator. Now you do have to be careful. When you use the exponent in the calculator, you need to make sure that that exponent's only getting applied to this 1.125. You might even want to do that first. You might even want to square 1.125 first and then multiply that result by 3.14. One way or the other, you will get 3.97 approximately. It's actually more than that, 3.98. Now, that's approximate, so I'm going to draw these squiggly lines to highlight the fact that it's actually not equals, but it's approximately 3.98. Now, that's the area of one pin base. Okay, but we know that we still are going to have to multiply that by 10. Now, 3.98, let's just be honest with ourselves. That is approximately 4. So really what we have to do is multiply 10 times 4. And of course, that's going to give us 40. And therefore the answer is A. Okay, problem number 24 asks, what is the ratio of the total area of the bowling lane to the area of the pin deck? Well, let's first of all keep in mind that ratios can be represented as fractions or with the colon, okay? Now, the answer choices in this particular problem feature ratios presented to us with a colon. However, I'm just going to say that let's temporarily use the fractional representation of a ratio first, because sometimes you can reduce this fraction, and you're typically going to want to do that before you convert it to the ratio version, or to the colon version, I should say. So we will begin, move this over, we will begin by finding out what would a good fractional representation of the ratio be. Well, it's going to be the area of the bowling lane. So I'll write that, area of bowling lane. I'll call it lane. It's going to be that over the area of the pin deck. Okay. And then we have to go on this mission to find each of these areas. Now, many of you at home know that the area of a rectangle is length times width, and that's really what we're dealing with. We're dealing with two different rectangles. Well, the first rectangle is the area of the lane, and the length times width when it comes to that one, I'll just write length times width here. Well, clearly that's going to be a length of 65 feet, as you can see from the diagram, times 3.5. Now I'm just going to call that 3.5. Okay, so that's going to be 65 times 3.5. And then there's the area of the pin deck down below. Well, let's call the length of that 5, and then it's going to be 3.5. Now, here's kind of an interesting thing that can happen at this point. Could we multiply this and get sort of a large number as a numerator and then 5 times 3.5 down below? Absolutely, we could do that. However, can't you see that we could actually just cancel these 3.5s right away, right? We could totally cancel these 3.5s because when you have multiplication in a numerator and multiplication in a denominator, you could do that kind of a cancellation. That actually is reducing the fraction, to be honest. So we have 3.5's canceling. And honestly, that leaves us with just 65 over 5. But check this out. We can reduce this even more. because 65 is absolutely divisible by 5, and we know that because the units digit is 5. Okay, so any number that has a units digit of 5 or 0 is divisible by 5. So the question is, okay, well, what is 65 divided by 5? Well, it turns out that 5 goes into 65 13 times. So this becomes a 13, and this becomes a 1. And therefore, we could actually represent this fraction as 13 over 1. Okay, so that really is the final fractional representation of the ratio. Now, as I said before, we have 13 over 1. That could be converted to 13 colon 1, 13 colon 1. And that is exactly why answer choice G is the answer. Now, before I move on, I do want to just say that when the test asks what is the ratio of the total area of the bowling lane to the area of the pin deck, that word to is key. Whatever word is before the word to is going to either be the numerator or the leftmost number in the colon setup. Whatever is after the word to, to, is either going to be the denominator in the fraction or the rightmost number in the colon setup. That's hugely important to understand. Problem number 25 asks, what score will Hallie need to earn in her third game to have an average score of 172 for the 3 games? Well, that's just a classic average problem. Well, standardized test average problem, to be honest. So when it comes to these problems, it's really important to remember the formula for the average. So an average is always going to equal the sum of values, okay, sum of values all over the number of values you're dealing with, okay? In this case, we're dealing with test scores, all right? Now, this is something that most of you listening learned a long time ago, but maybe there wasn't much emphasis on using the equation. I'm going to tell you right now that for any standardized test, whether it's the ACT math or the SAT math, get used to using this equation. This equation turns out to be really, really helpful, probably more helpful than you would expect. So the question again asks, what score will Hallie need to earn in her third game to have an average score of 172 for the 3 games? So we already know what the target average score is. That's going to be 172. So you actually put that where the big A is, 172, because that's the target average that we want at the end of the day. So that's going to equal the sum of all the test scores, which we're going to talk about in a moment, but it's going to be that divided by the amount of test scores that we're taking into account, or the amount of games. It's actually not test scores, is it? It's games. So the amount of, we'll just say scores that we're taking into account. That's 3. So there's 3 scores, okay? 3 scores that we're taking into account. All right, it's bowling. I actually forgot this is about bowling. So then we're going to add the sum of those 3 scores up top. Now, turns out we only have the first 2, right? We have, looks like 148 for the first one, and we have 176 for the other one. And then we're going to be adding the third one. Let's just call the third one X, because we actually don't have that, do we? Right? We actually don't have that. So that's the unknown. Then on the next line, we're going to say, okay, 172 equals something divided by 3. And what we're going to do is add 148 plus 176. And that turns out to be 324, actually. And it's still going to be plus X. Let's not forget that X right there. Now, kind of an interesting situation here. Your algebra skills do need to be on point. You need to recognize that, well, we are trying to solve for X, but how are we going to get X by itself? In fact, we're going to try to get X by itself on the right-hand side of the equal sign. And, you know, because it's already there. So, like, why not? And what you have to do is get rid of this 3 first, okay? Because if you could just get rid of the 3, then we would have 324 plus x by itself on the right-hand side. And then we could take it from there, all right? So in order to get rid of this denominator of 3, I would strongly advise multiplying both sides by 3 itself, because this is divided by 3, and the opposite operation of division is clearly multiplication, and that's how you cancel stuff in algebra. You got to do the opposite. So we're going to multiply both sides by 3, and this cancels, this cancels. That's the whole point, actually. We are stuck with 3 times 172, and that turns out to be 516 over there. Now, again, we had canceled these 3's out, so on the right-hand side, we have 324 plus x. Now, obviously, at this point, we're just going to be subtracting 324 from both sides of the equation, and that's going to leave us with x equals 192. And that's the answer, actually. That is the score that this person needs to get in order to have a total average of 172. And that is exactly why the answer is D. Problem number 26 asks, how many meters wide is the rectangle? So let's draw a rectangle. Okay, and we know that the area is 300. And we also know that the length, and we'll call this the length, okay, this will be L, and this is the width. So we know, apparently, that the length is 3 times the width. So that's something you could immediately write off to the side. The length equals 3W. And then they want to know, again, how many meters wide is the rectangle. So ultimately, we're trying to find W. Well, the good news is this is a very straightforward substitution problem, because the truth of the matter is, yeah, sure, it's like, okay, 300. And we know that this is W. And we know that this is the length, but we also know that the length equals 3W. So instead of writing L, I'm going to write 3W, because anytime you're originally dealing with 2 variables, anytime you could change that so that you're only having to contend with 1 variable, it's usually going to be a good idea. So from here, all we have to do is remember that the area of any rectangle is length times width. And the area of this rectangle is clearly going to be length times width, but the length is 3W. So that's actually going to be 3W times width, okay? Because again, the length is 3W in this particular rectangle. And that's going to equal 3W squared, okay? So let's be very clear. We're not adding these two. If we were adding 3W plus W, it would be 4W. We are multiplying these two. So we're going to end up with this W times W situation, which is just W squared. Now, the truth is we actually know the area, right? The area is 300, right? So sort of over here, I could just write 300, because we know that it equals 300, right? And solve this equation straightforwardly. I would suggest dividing both sides by 3. That would cancel these, leaving us with, I'll just move this a little bit, leaving us with W squared equals 300 divided by 3, which is 100. And at this point, in order to solve for W, we're going to have to get rid of this exponent of 2. And the way to do that is to take the square root of both sides. Now, out of habit, you should absolutely do this plus minus thing. Anytime you take the square root of both sides, you put plus minus on the other side of the variable that you're trying to solve for. Okay, so the variable we're trying to solve for is W. So on the other side, when you do the square root of both sides, you have to put plus minus. Okay, so this turns into plus minus 10. Okay, So the square root of 100 is 10. So this is either positive or negative 10. Now it turns out that this is a real world problem dealing with an actual rectangle. So we're only going to consider the positive version of that. Okay. We're only going to consider the positive width because it doesn't make sense to have a negative width in this particular problem. So the truth is that positive 10 equals W for this problem. Now you might be wondering why I insisted upon this plus minus thing. I'm just going to ask you to trust me. Out of a habit, always do the plus minus thing. And then once you get this far, then ask yourself, okay, do I have to only pick one of these or are both of these true? There are algebra problems in the future where this would be the answer, where it's like, oh, W is clearly equal to either positive 10 or negative 10. It just so happens that this is a geometry problem featuring real world dimensions of a rectangle. Therefore, we only need to take into account the positive. So anyway, I think you get the idea. The answer for this is F. Answer choice 27 asks, if it can be determined, what are the lengths in inches of the other three sides? Well, first of all, we're dealing with a parallelogram, so I'm just going to draw a generic sort of parallelogram that looks like that. Apparently, one of the sides is 16. And they're like, oh, if it can be determined, what are the lengths in inches of the other three sides? Well, first of all, this is 16. Okay, because that's one of the features of a parallelogram is that the opposite sides are of equal length. Okay, opposite sides are of equal length. So that has to be 16. And also, by the way, these have to be the same as well. So we're just going to call those X and X. So what we're doing is we're taking into account what are these dimensions, okay? Now I called this X because we don't know what it is yet. Okay, we don't know what it is yet. And I'm calling this X as well because not only do we not know what it is, but we do know that it's the same as that. Okay, so we're just going to call that X. And the good news is they actually do give us enough information because they give us the perimeter. Now the perimeter would be the sum of all side lengths. I'll just call it sum of side lengths. Okay. I like to think of the perimeter of a polygon to be like a question of how long the fence would be. If you were to wrap the polygon up with a fence, well, how long would that fence be? That's basically what a perimeter is. Okay. Well, we have a good amount of information because the perimeter we know is 96. They actually give you that in the problem. We also know that the perimeter is a result of adding 16 plus this 16 plus this X plus this X. Okay. So it's going to be 16 plus 16 plus X plus X. And for the record, I could have written that in any order I wanted to. Okay. Because addition is commutative. Therefore, the order doesn't really matter. In other words, I could have written 16 plus X plus 16 plus X. That would have been fine as well. But one way or the other, we do have to combine like terms. These are like terms because they're both constants. So we're going to combine them, also known as add them. So it's going to be 32. And it turns out that these are also like terms as well. X plus X is 2X. Okay. And I think most of you could probably take it from here. We will be subtracting 32 from both sides in order to get that 2X by itself. In doing so, we cancel that. Then we're left with 2X equals 96 minus 32. Well, that's going to be 64. At that point, we will be dividing both sides by 2 in order to get X by itself. That cancels the 2's, giving us X equals 32. So that means that the parallelogram really could be labeled such that we have a 16 on top, we have a 32 over here, a 32 over here, and a 16 down below. Now this black 16 is the one that they gave us in the beginning. These are the other dimensions that they're sort of asking about in the problem. They're like, what could be the other three lengths? Okay, well here they are in red. These are the other three lengths based off of this algebra stuff. That is why answer choice C is correct. Problem number 28 asks, how many feet wide is Elmhurst Street? So I think you should draw it. I gotta be honest. think you should draw it. We're going to draw it one piece at a time. First of all, it's a two-way street. You know what that means? That means there's like the divider dotted yellow line thing in the middle. Okay, it's two lanes. Now it's either the dotted or the solid yellow line. Let's just imagine it's a dotted though. Okay, two lanes. And apparently in each direction, it has one 12-foot wide lane. So we're just going to focus on the right side. It's got a 12-foot wide lane from there to there. I'll just do this kind of dotted line there. Then apparently that's for car traffic. Then apparently it's got one 6-foot wide bike lane. Okay, so I'll do that in green actually. So this is 6 feet over there. That's for bicycles. Okay, I'll draw a little car. Yeah, it's a car. It's an amazing car. And this is bicycle land. Bicycle land is over here. We got the seat. We got the thing with the handlebars, and it goes like that. Okay, so that's for bikes. And then there is, what is it? An 8-foot wide parking lane. 8-foot wide parking lane. So that is right here. Okay. And, parking lane, let's imagine it's like parking spots that are like diagonal like that. All right, sometimes they're like that. Okay. Now, when you're doing this problem, do you have to get into this level of detail? Absolutely not. I only am doing it to make it easier for you as the viewer. But when you're doing it, maybe just draw, 3 rectangles like that, or rectangle looking columns kind of thing. Okay. So we know that the street, like one half of the street is this, and we know that it's repeated on the other side. Now I'm not going to bother drawing the other side, but remember it's 2 lanes. So all this stuff that's happening over here, it's also going to be happening on the other side, right? So really what we could do is just add 12 plus 6 plus 8, and then multiply that by 2, and then we'd be done. So 12 plus 6 is 18. 18 plus 8 is 26, and 26 times 2 is 52. So we know the answer is 52, and that is answer choice H. Okay, problem number 29 asks, if there are 2,500 students at Central, how many of the students are freshmen who ride the bus? Okay, so basically, you're starting with 2,500. But then I'm going to wrap it in parentheses because I can already see this is going to be a multiplication situation. And we're going to be multiplying this by fractions, okay? So apparently 4 out of every 10 students ride the bus in the first place. So what we're going to do is we're going to find out, okay, how many students ride the bus in the first place? Well, it's definitely 4/10. 4 out of 10 is the same as 4/10. It's 4/10 of 2,500. I'm going to say let's just start with that. Let's just start there. Let's find out how many students ride the bus in the first place. Well, you could use a calculator, but you could also realize, okay, well, one of these zeros cancels with the 10. So it really becomes 250 times 4. Now, 250 times 2 is 500. So 250 times 4 is twice that. So 250 times 4 is 1,000. Now, again, if that's confusing to you, use a calculator. All right, or do it old school, right? 250 times 4, and do it the old school way. So 1,000. 1,000 students ride the bus in the first place. Okay, ride the bus. But then a certain fraction of these, according to the problem, are freshmen. And according to the problem, it's 3 out of every 8 of these people. Okay, the precise wording they used is 3 out of every 8 who ride the bus. Okay, well, there's 1,000 people who ride the bus, and it's going to be 3 out of every 8 of those who are freshmen. So then we have to do another problem with multiplication, where it's going to be 1,000 times 3/8. I'll keep it in yellow for now. And that should be the answer, actually. So that's going to be 3,000 over 8, because the truth is there's secretly a 1 underneath there, okay? And then 3,000 divided by 8 is 375. Now for this one, if you wanted to just use your calculator for everything, that would have been fine, okay? 375, so therefore the answer is A. Problem number 30 asks, what is cosine of theta? Okay. Well, before we even dive in, let's just remember our famous acronym called SOHCAHTOA. All right, now let's temporarily forget the problem. We're not going to worry about it just yet. And just remember what this means, because this is going to come into play a lot with trigonometry problems. So sine of theta equals opposite over hypotenuse, cosine of theta. And theta in this case, don't be thrown off by this symbol. Some of you might be a little bit more used to like an X there. Just know that this is the angle measure, okay? Usually in degrees. It's typically in degrees, okay? So just know it's cosine of an angle, whatever that angle is. Same with the sine. So the angle measure always goes here, okay? Anyway, according to SOHCAHTOA, sine of theta is opposite over hypotenuse. That's because it's OH here next to the S. We have CAH, which means that it's adjacent over hypotenuse. Okay, that's what that means. And then we have tangent of theta, which is opposite over adjacent. Okay, opposite over adjacent. This is the main thing that you're going to have to really keep in mind, I would say, for this particular problem. I'm going to wrap it in blue just to sort of separate it from everything else. And some of you might be wondering, well, what the heck does all this mean? Opposite, hypotenuse, adjacent, etc. And that will become clear as we proceed. So sine of theta is 20 over 29. That's one piece of information. The other piece of information they give you is that theta is between 90 and 180. Now, what that tells me is this is a little bit more of an advanced trigonometry problem than just a straightforward trigonometry problem where you have to draw like a right triangle and, make sense of it from there. Unfortunately, we are going to have to get a sense about what's happening on this coordinate plane, where basically in trigonometry, you'll typically call this your starting point, and then you're going to open an angle from there. So if I opened an angle from there, it would be like 90 degrees. Okay, so a 90-degree angle starts here, opens counterclockwise, and then lands in that 90-degree position. If I wanted to open a 180-degree angle, I would open an angle that goes all the way like that, and then lands right there, and that would be the resting place of that angle. But keep in mind, it always starts here and it goes counterclockwise if it's a positive degree angle, okay? Now, apparently this theta is between 180 and 90. So this thing opens and lands somewhere between the sort of 90-degree mark and the 180-degree mark. So we're dealing with an angle that opens like that. Okay, now you might be wondering, okay, great. And then they say sine of theta, and this is theta, by the way. The angle that we just opened, that is theta. Now we don't know what the measure of that angle is, but it's between 90 and 180. I don't know what to tell you. It's obtuse, okay, and it opens like that. Now they're like, oh, sine of theta is 20 over 29. Okay, so how can we represent that piece of information? Well, whenever you're doing this kind of trig stuff with the coordinate plane, I like to think of a bow tie, okay? Because whenever you're using the coordinate plane, well, yeah, you have your starting point there, and then you open here, and then you might land somewhere, but wherever you land, you then focus on the triangle that you just formed. And it's going to be one of these bow tie triangles. There's really 4 triangles here. There's one here, there's one here, there's one here, there's one here. So when you open an angle, let's say you land down here, well, then you're going to focus on this triangle. So we're opening here, we land here, so that means we're going to take into account an imaginary triangle, a right triangle, that's like that, okay? And I'm going to even shade it in, okay? I'm going to shade that in. we're going to take into account this triangle. That's going to be super helpful for us. Okay. Now, what did they tell us about this triangle? This triangle, the angle that we want to focus on is this little guy right here. Okay, that's the case with any of these triangles. You always focus on the angle that's closest to the origin. Now, apparently, the sine of theta is 20 over 29, but we also know that the sine of any angle is the opposite over the hypotenuse. So what that means is this hypotenuse right here could be conceptualized as 29 units long, and the opposite, which is the side length that's across from the angle, across from the origin, we could say too, that is the opposite side, so that's going to be 20. So now they're asking, oh, what about cosine of the angle then? You know, what's cosine of this angle? Well, the cosine is adjacent over hypotenuse, and this is the adjacent because it's adjacent to the angle that's at the origin, right? So that's going to be the adjacent angle. In fact, I'm going to call it A, okay? Now, if we just knew what A was, then we'd be done. I mean, it'd be like cosine of A over um, the hypotenuse, and we already know the hypotenuse, it's 29. So it would be A over 29, and then we'd be done. The problem is we don't have A, so we got to find A. So how could you find A? Well, you could bust out the Pythagorean theorem. The Pythagorean theorem says that this side length squared plus this side length squared equals the hypotenuse squared. So we're going to set that up. So down here it's going to be A squared plus 20 squared equals 29 squared. And then we will take it from there. So A squared is just A squared. We're kind of stuck with that. 20 squared is 400. So that's going to be 400. 29 squared is 841. Subtracting 400 from both sides would give us A squared equals 441. And then taking the square root of both sides, square root plus minus, just to get in the habit, that's going to be A equals the square root of 441, which is 21 actually. So this side length right here is 21. So instead of writing A, I'm actually going to erase that. I'm going to erase that. We're going to put 21 right there. But here's the thing. Before we start thinking we're done, this is 21 in this left direction. Do you see how it's traveling in this direction? It's 21 to the left of the origin. So that's negative. That's actually negative. Okay. Now you might be wondering, what about the hypotenuse? Is the hypotenuse negative? No. The hypotenuse number, the number associated with the hypotenuse, is never negative. Ever. It's always positive. But this leg is going to the left, so that's negative. This leg is going up. This 20 is going up 20. That's positive. This leg is going to the left 21. That's negative. So cosine theta is negative 21 over 29. Okay, boom. Now, this is a relatively challenging problem, I have to say, relatively speaking, with the other problems on the ACT. If you were completely lost, then I would strongly suggest practicing your trigonometry. Just get the practice in. If you're relatively new to this, understanding what I just did won't be enough. Okay, understanding what I just did won't be enough. You will have to practice these concepts. And you might be wondering which concepts. Well, certainly you're going to have to study the trig functions of sine, cosine, and tangent, and so on. But you're also going to want to understand the trig function as they relate to the xy coordinate plane, okay? Now, since the answer is negative 21 over 29, the correct answer, as far as the answer choices go, is H. Problem number 31 asks, what are the real values of t for which f of t equals t? Okay. That is such an annoying problem. Let me write the original function. All right, here's the deal. Some of you might be wondering, what the heck are they even talking about? Well, first of all, anytime they're like f of whatever, let's forget about the fact that f of t equals t. Let's actually forget that. Let's focus on what we know about functions. Anytime they say f of t and they gave you a function, that means replace x with t. That's what it means. Whatever is in here, if that was a 3, it would be f of 3. And then we'd be replacing x with a 3. In this case, it's f of t. So we're just going to go ahead and replace x with a t. All right. So, good. We are just doing what you're supposed to whenever you have f of whatever. Okay, you replace x with that whatever. But then they go ahead and they say, oh, by the way, that equals t, right? Don't they say that? They say f of t equals t. They literally say that. So we could write that it equals t, right? Because that's true, right? F of t equals t. F of t also equals this thing. So I would suggest from here on out, let's just focus on these two guys and then solve for t, because they're like, what are the real values of t for which this whole thing is true? That's basically what they're asking. What values of t are such that this whole thing is true? Well, therefore, we're going to have 2 over t plus 1 equals t, and then just solve for t. We can kind of ditch this f of t because we now have an equation to work with. And we're going to do that right now. Okay, so that's what we're dealing with now. We're about to solve for t. Now, whenever you have stuff in the denominator like this, or let me just put it this way. Whenever you have the variable that you're trying to solve for in the denominator, you might want to get it out of the denominator. Well, how do you do that? Well, you multiply both sides of the equation by the denominator itself. So that means we're literally going to multiply each side of the equation by t plus 1. Okay? Now, let's look at what happens. I understand this might look complicated, but it's actually not. The good news is these just cancel. That's the whole point of doing it. So we have 2 equals whatever t times t plus 1 is. Now, the truth is we can distribute this t to both. Okay? So that's going to become t squared plus, t times 1, which is just t. Okay, so at this point, we have 2 equals t squared plus t. This is a quadratic trinomial. It's quadratic because the largest exponent is 2, and everything's on one level and so on. It's a trinomial because there's 3 terms. There's a t squared term, there's a t term, and there is a constant called 2. When you're solving quadratic trinomials, it's going to be a good idea to set the whole thing equal to 0. So let's make sure that 0 is on the left-hand side because we want this t squared term to be positive. And also it's easy to put a 0 on the left-hand side because all we have to do is subtract 2. I'll reiterate, whenever you have a quadratic trinomial, you're going to want to set it equal to 0. So we're going to subtract 2 from both sides, leaving us with a 0 over here. We have this t squared plus t still. Nothing changed about that, but we have this minus t. So we have a minus 2 right there. At this point, we have options. We can either use the quadratic formula, we could complete the square, But we could also factor. We might find that we can factor this. And I'm already seeing, based on just experience, that this is factorable. Okay. Now, the question you want to ask yourself, if you want to find out if this quadratic trinomial is actually factorable in the first place, is you ask yourself, are there two numbers that multiply to -2, but add to this invisible 1 that's in front of this t? And it turns out that there are. So there is +2 and -1. Now, a lot of you watching might be used to just realizing immediately that you could sort of take the opposite sign version of each of these numbers and call that the answer. And that is true in this case. In reality, though, what you're doing is, for example, like let's say we're focusing on this one, the reality of what you're really doing is setting each expression separately equal to 0 and then solving for t, and that turns out to be t equals 1. So that's important to remember, because you can only do that trick where you just take the opposite sign of the number if it's the case that the coefficient in front of this t is 1 and the coefficient in front of this t is 1. The one thing that will work every time is setting each expression equal to 0 and then solving for t. All right, so that is what t equals, -2 and 1, and that is why the answer is C. Problem number 32 asks, which of the following values is closest to the distance in feet between the two radar stations? So the two radar stations are right here and right there. So it's these. So what we're looking for is the distance between A and B. Now, of course, we already have 9,000, so it would be good to have this segment right here, dB. And the way that you could do that is by simply focusing on this triangle, which we know is a right triangle because this is a right angle, and this angle right here, CDB, is a linear pair with CDA, and therefore they are supplementary, and therefore this is also a right angle. So this is a right triangle. And you could definitely use the Pythagorean theorem. You could realize that 12,000 squared plus whatever this squared, whatever this is squared, equals 13,000 squared. However, that would kind of be a little bit tedious. I think it's going to be helpful to remember that one of the special right triangles that's worth memorizing is called a 5, 12, 13 triangle. And that is what we have here. So this is 12,000, this is 13,000, so it makes sense that this would be 5,000 right there. So all you have to do, of course, is just add 9,000 plus 5,000, and you're good to go. And that is something a lot of you could probably do in your head. That is 14,000. So that's why the answer is J. Problem number 33 asks, which of the following equations represents the line along which the airplane is flying? Well, that would be this line, right? So it's this horizontal line. So the first thing to note about it is that it's horizontal. And anytime you have a horizontal line, that always takes the equation at least takes the form of y equals k, where that's some constant, it's just some number like 10 or something like that, okay? So that's the first thing to understand about this problem. And for that reason, you can immediately eliminate A and B, because A and B actually are the equation of vertical lines. Okay, anytime you have x equals some constant, that's a vertical line, but clearly we're dealing with a horizontal line. Now, the constant k for any horizontal line like that one, the constant k is the y value that the horizontal line cuts through on the coordinate plane. And they're essentially asking you to envision a coordinate plane position such that the origin is right there, and it kind of goes down obviously forever, and maybe it would continue in this direction and so on. So that's the coordinate plane scenario that they want. So the thing that you need to figure out in order to figure out the equation of this horizontal line is, what is this y value here? What is that, um, you know, value right there on the y-axis? And then, let's say that y value was 13, which it's not, but imagine it was. Well, then it would be y equals 13, and that's the answer. Okay, that's how it works. So our mission is to figure out, what is this y value? Well, the y value, that this green horizontal line representing the path of the airplane, this y value is a certain amount of units up. Well, that's the same amount of units as this, right? So the key is to figure out, what is this length right there? And if you could just find this length from bottom to top, whatever that length is, that's the actual number, right? In the same way that if that was 13, if you go 13 from the origin up, well, you would land right there, right? So our goal is to figure out, well, what is this length here? Well, the length is labeled. We don't even have to use the Pythagorean theorem. It's 12,000. Okay, that's all you have to do. It's 12,000. So in a way, this problem is really just quizzing or testing your ability to understand what the equation of a horizontal line is, to understand that it's y equals some constant, and to recognize that the equation of a horizontal line, the constant that you need to write in there, basically just has to do with the height of the horizontal line. Okay, so the answer for this one, therefore, is C. Problem 34 asks, which of the following values is closest to the number of seconds it will take for the airplane to fly from C to the point directly above the radar station at A? So here it is at C, and it's going this way. And we want to know, how long will it take for it to get from C to this point that's directly above A, because A is this point right here. Okay, so that's essentially asking, how many seconds will it take for the plane 9,000 feet? Now, they actually give you the speed. The speed is 300 feet per second. And this is a fairly straightforward rate times time equals distance problem. In fact, I'll write that: rate times time equals distance. And all we have to do is just simply use this equation to find the answer. So the rate we know is 300. It's 300 feet per second. The time we don't know. That's what we're trying to find out. So I'm going to call that lowercase t. We do know the distance that the plane is traveling. It's definitely going to be traveling this 9,000 feet here. Now, it's up here, but that's 9,000 feet because down here is 9,000 feet, okay? So 9,000. And then you just, divide both sides by 300. And then you would have 30. So approximately 30 seconds is how long it would take for the plane to travel from point C to the spot directly above point A. And that is why the answer is G. Problem number 35 asks, which of the angles below increases in measure as the airplane flies due west beyond the point directly above A? All right, so in other words, they want to know, as the airplane goes further and further this way, well, the triangle is going to kind of morph as a result. And, the plane is most definitely staying on this kind of horizontal path, right? So we're going to imagine what happens when the plane is like here. How does that change the triangle? Well, the new triangle would look something like that. And as you can see, angle B has decreased. It used to be this larger angle, but now it's just this little acute angle. Okay, angle ABC, I should say. So this is the new C. I'll put a C. We'll say C prime. Okay, so it's over there. Now, this angle is now smaller. I would say it looks like angle ACB. This is smaller too. That looks more acute. Okay, that's more acute. This is larger. Okay, angle ACB used to be a little bit bigger, but now it's this acute angle. So angle B has decreased. Angle C has decreased, but they want to know which of the angles increases. Well, that leaves angle A, or we could say angle CAB. Once the plane moves over here, it's really C prime, that's the new position. That's C prime AB. That's this larger obtuse angle. It's clearly an obtuse angle at this point, okay? So that is why the only angle that actually increases as the plane moves due west is angle A, okay, angle A. So that is why answer choice A is correct, okay? And that's how you do that one. Okay, so 36 asks, the length of Troy's new poster will be 3/4 the length of the original poster. How many feet wide will the new poster be? Well, apparently the new poster is going to have an area that's 50% of the area of the original poster. And the original poster was 4 feet by 2 feet. So you can imagine something maybe that looks like this, where the original poster was this. And clearly that had an area of 8. So 2 times 4 obviously is 8. And we want to have a new poster that is 50% of the area of the original one. And most of you watching know that 50% is really half. So half of 8, obviously, is an area of 4. And then they tell us that the length of the new poster will be 3/4 the length of this poster, 3/4 the length of this one. Well, the length of the original one is 4, and 3/4 of 4 is 3. Now, in case you're not sure how I know that, you could sort of ask the question, what is 3/4 of 4? And the word of, interestingly enough, means multiply. So the real question, therefore, is what is 3/4 times 4? Turns out these cancel, and then you have 3. And if you're wondering how these would cancel, well, the whole number of 4, just so you know, could be temporarily treated as a fraction that just so happens to have 1 in the denominator. And whenever you multiply fractions, there's always it's always worth looking to see if there's an opportunity to do that cross cancellation stuff. And there was, and it turns out that 3 is 3/4 of 4, which is why that's the new length. And then the question is like, oh, okay, well, what's the new width going to be? So let's actually label that W. Now, one thing's for sure, we know as a fact that the formula for area of a rectangle is length times width, and we know that the area of our new poster is 4, and we know that the length is 3, and then the question is, what's the width? Well, pretty straightforward, just solving for W at this point. We would do so by dividing by 3, canceling there, and then we have W equals 4/3. And that is why the answer is, drum roll, one of the two mixed numbers, okay? Because 4/3 does not show up in the answer choices, but there are two mixed numbers there, which basically means we have to convert this to mixed number. And how do you do that? Well, you have to treat it temporarily like a division problem and literally divide 4 by 3. How many times does 3 go into 4 without going over? Well, that would be 1 time. And then long division would have you multiply 3 times 1, which is 3. Subtracting 3 gives you 1. So we now have our remainder, and that turns out to be Looks like it's going to be 1 and 1/3 because the denominator of 3 will always remain the denominator in the mixed number. The remainder is going to be the numerator in the mixed number, and the quotient of 1 is going to be the large number in the mixed number. And that is why the answer to this problem is G. Number 37 asks, what is the solution set of the equation? So I understand that the fact that they're using the word set might be somewhat confusing, but if your original instinct was to just go ahead and see what happens if you solve for x, I would say that's a good instinct, and that's how we're going to begin. So first of all, here's the equation, of course. And at this point, we can distribute that 2 here and here. And typically, you're going to want to simplify both sides of the equation before you do anything else. Usually, I'd say at least like 99% of the time. Especially if you're relatively new to math, you're just going to want to simplify both sides. The equation, so 2 times x is 2x plus 6 minus x. Let's commit to having the x's over on the left, although before we do that, let's actually simplify this further because this could be simplified further. So let's keep the x plus 6 over here, actually. I'm thinking out loud. Now, 2x and negative x are like terms. You could combine them, giving you x, and then we still have this plus 6 right here. Okay, so at this point, we have x plus 6 on the left and x plus 6 on the right. So anytime you end up with the exact same expression on each side of the equal sign, that means there are infinite solutions. Now, in case you're wondering how that is, it's actually not that difficult to see why, okay? Because when we say infinite solutions, what we really mean is x could be anything, okay? That's really what it means. X could actually be anything. X could be any of the infinite numbers to choose from. And the reason is because imagine x was 500 million. Well, when you add 6 to it, it's going to be 500 million and 6. Well, is that going to equal this? Well, yeah, 500 million and 6 would be over here too. So you could put any number in for x, and it would result in this equation being a true statement. Okay, that's a good way to think about it. You could substitute any number in for x, and this equation would remain a true statement. So therefore, we can say that x could be anything. There are infinite solutions regarding what x could be. And instinctually, many of you would probably recognize that E is the answer. Now, let's look at the answer choices nonetheless. Answer choice A says the empty set. Well, first of all, what is a set? A set is just a list of numbers, often with a characteristic, some kind of a trait or characteristic. But that's it. Set is just a list of numbers, and they use these weird sort of bracket-looking things to, encapsulate the list of numbers in the set. And the empty set is the set that contains nothing. It's almost like a zero concept. Zero is an interesting concept. It's like, what is zero? Does it even exist? I don't know. I'll let you think about that one. Does zero exist? If so, well, where is it? If not, then what are we even talking about when we say zero? So that's kind of an interesting thing to think about. But the empty set is kind of like that, where it's like the set of nothing. And clearly that's not what we're dealing with here, because we're dealing with infinite solutions, right? We have the opposite of nothing going on. Answer choice B literally says that x equals 0, okay? Answer choice B essentially says, yes, there is one answer, x equals 0, okay? And then answer choice C says the answer is 2, answer choice D says the answer is 3, and then answer choice E says the set of all real numbers. Now, for the sake of simplicity and being thorough, I will tell you real numbers are all the numbers that could hypothetically be found on a number line. Okay, if you imagine a number line with 0 in the middle, perhaps, and these tick marks representing integers, whether it's 1, 2, 3, or -10, -7, and so on. The set of all real numbers would be any number that could be found on that number line, including the numbers in between the tick marks. Okay. So anyway, that is how you do number 37. Okay, so for problem number 38, one way of going about it is to use a system of equations and substitution. So first of all, the perimeter of any rectangle is 2L plus 2W, 2 times the length plus 2 times the width. Okay, that's the perimeter. It's also the case that the area of any rectangle is L times W. Now, for the perimeter, we actually have the perimeter for this particular rectangle, this fencing enclosure, because we have 28 feet of fencing, which means that the perimeter will end up being 28. And then we have 28 equals 2 times L plus 2 times W. And at that point, what I would actually suggest to make your life easier is to factor out the 2 here. Okay, so we're going to have 2 times L plus W. And then at that point, you can divide everything by 2. And that leaves us with L plus W equals 14. Now, you might be wondering, okay, where's this going? Like, how is this remotely helpful? Well, what we have on our hands is a system of equations. We have 2 different equations that feature the same variables, okay? And one thing you can do when you have a system of equations is what's called substitution, which means you pick one of the 2 equations and you solve for one variable in terms of the other. Now, it so happens, and after that you substitute after that. So it so happens that we could choose either W or L. It doesn't matter. I'm going to go ahead and solve for L in terms of W. And the way that I'm going to do that is by subtracting W from both sides. Next thing you know, I have, because these cancel, 14 minus W. So I haven't done anything to change the value of anything. I mean, this just got rewritten. That's all. It just got rewritten in such a way that's going to make it easy for us to substitute. Now, where are we going to substitute? We're going to substitute over here. So we're going to rewrite this as A equals, and I'm going to write empty parentheses this time. So we're still going to have our W here. So that's going to be W. But instead of writing L right here, we're going to write 14 minus W because we know that L equals 14 minus W. So we can do that. And then at that point, what you're going to want to do with a problem like this is you're going to want to distribute here and just simplify this. Okay. So we have the area equals 14W minus W squared. Now, for the record, that could be rewritten as the area equals negative W squared plus 14W. Now, that's a little crazy, I understand. But for those of you familiar with parabolas, this is a good way to go. Now, before we get into it, quick review. Oftentimes, parabolas, or the equation of a parabola, will be written like this. And that's the standard form. And this right here would be the y-axis, or the y-intercept, I should say, not the y-axis. Okay. So this would help us see whether or not, or where on the y-axis the parabola crosses over. It's also the case, by the way, that you could find the axis of symmetry by putting negative b over 2a. Now, in case you're not clear what the axis of symmetry means, imagine we had a parabola that was like that. Maybe the y-intercept was at 5, and perhaps the vertex was at 2, 1, the axis of symmetry would be this vertical line that cuts through and intercepts the x-axis at 2. All right, so that's the axis of symmetry. It's the vertical line that would cut through the vertex like that. And maybe the formula or the equation for this would be something like x squared minus 4x plus 5, where clearly we could see that 5 is the y-intercept, and if we wanted to find the axis of symmetry, once again, all you'd have to do is set x equal to negative b over 2a. Well, b is the coefficient of the x term, a is the coefficient of the x squared term, so if I was to do the axis of symmetry, it would be x equals negative 4, because that's b, over 2a, and that's 2 times 1. Now, in case that's not clear, the b in this case, which is the coefficient of the x term, is negative 4, and the a in this case is the coefficient of the x squared term, which is this invisible 1. So I place my b here, and I place my 1 there. Notice how it's negative b. Negative b. Now b happens to be negative 4, so it's going to be negative 4. So you have to be super careful with the signs, and that would turn into positive 4 over 2, and that would give you 2. And that makes total sense because the axis of symmetry is at 2, and there is indeed this vertical line that cuts up through the x value of 2. Now, it is the case that this number is also the x-coordinate of the vertex, okay? Now let's talk about the vertex. The vertex is this moment where the parabola changes direction, right? Now in the case of this sort of upward facing, upward opening parabola, the vertex would be at the minimum, okay? It's like the valley of the parabola. It's the smallest kind of dip in the parabola. It's the smallest y value in the parabola. Whereas if you had an upside down parabola, well, the vertex would clearly be here, and that would represent a maximum, okay? Now, how do you know when you have an upward-facing parabola or a downward-facing parabola? Well, you know by whether or not this a coefficient that's in front of the x squared, you would know if that's positive or negative. If this is positive, then it's going to be upward-facing. If this a is negative, it's going to be downward-facing. So the reason why this one was upward facing is because there's a positive 1 in front of there. Now, that's a quick sort of overview of some of the things that become useful in this problem, some of the things that are useful to know in this problem, because here we are, we've used a system of equations to get this far, where the area equals negative w squared plus 14w. I'm actually going to begin the process of conceptualizing what that might look like. Truth of the matter is, we know it's going to be a downward facing parabola because the coefficient of the w squared term is negative. And we also know that the y-intercept is 0 because I had told you before that the y-intercept corresponds with the constant that's at the tail end of the standard form parabola equation. Well, there is no constant, which means it's secretly a plus 0 over here. So that means we have a y-intercept of 0. We have a downward facing parabola with a y-intercept at 0. Okay, so it's something like that. All right, it has to be something like that. In order for it to be a downward facing parabola that cuts through the y-axis at 0, it's got to be represented like that somewhat. And let's get a little bit further into the detail. This is the a-axis, which stands for area, and this is the w-axis, which stands for width in this case. Clearly, we can see that the maximum area, which, by the way, that's what we're interested in this problem, is the maximum area, takes place right here at the vertex. Okay, so we have this vertex right there. Now, the vertex corresponds with the axis of symmetry, which would be easy to find. Remember, the axis of symmetry is found by setting x equal to negative b over 2a. Well, in this case, it's going to be setting w equal to negative 14 over 2 times negative 1, all right? Because 14 is the coefficient of the w term, and negative 1 is the coefficient of the w squared term. So from there, we end up with negative 14 over negative 2, which turns into, keep it w here, w, that turns into 7. So we know that the width that corresponds with the maximum area is 7, okay? I'll say that again. We have just proven that the width that corresponds with the maximum area is 7. Now, if that's the case, what is the maximum area that corresponds with this width? Well, it's very simple. All you have to do is take this 7 and plug it in to the equation that we have, okay? And what you will find is it turns out to be 49. So I'm going to do a little asterisk. I'm going to bring the equation down here, and we're going to look at it. So I'm going to write a equals, instead of negative w squared, I'm going to write negative 7 squared. And then it's going to be plus 14 times 7. Now, this turns out to be negative 49. And 14 times 7 is 98. So from that moment, we can just subtract 49 from 98, and that would become 49. Okay? So that's how you find the maximum area that this could be if you have a perimeter of 28. Now, for those of you unfamiliar with problems like that, it's totally understandable if it could be overwhelming. I suggest studying things like graphing parabola when it's written in standard form, not vertex form, but standard form. I would suggest researching, or practicing finding the axis of symmetry. Anything that has to do with letting you know that the vertex is a maximum, and so on. And of course, you could always just rewind this, watch it again, make sure you're following every step. The big picture, though, is that we set up a system of equations where it was 28 equals 2L plus 2W, and A equals LW, okay? So this was the original system of equations, and then we just used substitution here, but we found ourselves in the midst of a quadratic situation, which means parabola, and notably an upside down parabola. And in this moment where I realized that after doing all the substitution, it turns out to be an upside down parabola, that's actually a relief, because it should be an upside down parabola where A corresponds with the y-axis, because we want something that has a peak. We want something that has a maximum, because that's what we're interested in. We're interested in the maximum area, right? So there should be a peak here. If there wasn't a peak, there'd be something wrong, right? Because that peak is what we're interested in, and notably we're interested in what value of W corresponds with that peak, and then we just take it from there. Okay, so that's how you do problem number 38, and the answer, of course, is J. Problem number 39 can be challenging if you're not terribly familiar with range, mean, median, and standard deviation. Now, very quickly, imagine we had this data set where 9, 10, 11, and we'll make this actually 12, okay? And let's say this is the data, and we want to get clear on what the range is. Well, the range is always going to be the difference between the largest and the smallest numbers. So the range in this case would be 12 minus 9, and that equals 3, okay? So that's the range. The mean would be what you get when you add all of that stuff. I'll put mean here. The mean would be what you get when you add 9 plus 10 plus 12, and then divide by the amount of numbers that you're dealing with, in which case it's 3. So that would be 31 divided by 3, which is, that is 10 and 1/3, also known as 10.33, repeating. And the median is always going to be the middle number. So in this case, it's the middle number of 10. Now, as many of you recall, if you have an even amount of numbers, so for example, if you had something like, 4, 5, 6, and 7, well, the median would be the average of the two middle numbers, okay? Now, the standard deviation, in this case, at least for the ACT, what you do need to understand with regards to the standard deviation is that it really just highlights how tightly clustered around the mean the data is. So, for example, we already discovered that the mean is 10.33, and that would be located right around there. And you can see that the number 9, 10, and 12 are kind of tightly packed around that 10.33 mean. Whereas if you had another data set, for example, something like the following, 2, 10, and 28, well, you can see how this data is clearly different than this data, but I will tell you right now, if you were to find the mean of this, it would also be 10.33, and that would be located around here, okay? And, but as you can see, these numbers are kind of more spread out. 9, 10, and 12 are really, all three of them are really close to 10.33, whereas 2, 10, and 28 are a little bit more spread out. I mean, 28 is pretty far away from 10.33, and 2 is actually pretty far away from 10.33. So when you're considering the standard deviation, you want to get a sense of, what is the mean and how far away is everything from the mean? Is it tightly clustered around the mean, like the above three data, or is it sort of spread out, sort of away from the mean, like 2 and 28 are? It's almost as though the mean is a magnet, and if the mean is a magnet that's really powerful, it's going to pull all the other data close to it. If the mean is a magnet that's less powerful, the data is going to get spread out a little bit further away from it. Now, when the data is spread out, we would consider that standard deviation to be relatively large. Okay, so the more of a spread there is, the bigger the standard deviation. More tightly packed the data is, the smaller the standard deviation is. Now, at the level of skill required for the ACT, you don't necessarily need to know the numerical value of the standard deviation, but you do need to know if the standard deviation is relatively small or relatively large. In this case, it's relatively small because the data is tightly packed around the mean, and in this case, the standard deviation is relatively large because it's a little bit more spread out. And in the case of our original data, which is 9, 10, and 12, what I'm actually just going to say for the standard deviation is that it's relatively small. Okay, so I'm going to say small. So that's a little bit of an overview of the range, the mean, the median, and the standard deviation. Now, as it pertains to our problem, we have 4 customers, or 5 customers rather, who make anywhere from 30K to 35K. And maybe this is 31K, 32, maybe this is 34K. Okay, so these are the first 5 customers in the store, but then all of a sudden this millionaire person walks in, like later. I'll represent that in a moment. But we can kind of see that in this case, the range would be 35K minus 30, which is 5K, we can see that the mean would be a result of adding all five of these numbers and then dividing by 5. So I'm actually going to find that right now. So the mean would turn out to be 32.4. Okay, so we'll just make a mental note of that. Um, and then the standard deviation, I would say, is relatively small because these numbers are pretty tightly packed around the mean. The mean is 32.4. I mean, all of these numbers are pretty close to 32.4. So that brings us to the millionaire. Okay, so the millionaire comes along and $1 million. Okay, so this person makes $1 million a year. And let's kind of think about which of the statistics would change as a result. Well, first of all, the range would change drastically because now it goes from 30,000 all the way to 1 million. So that is a huge change in the range. In fact, I would say that's the biggest change out of all the statistics. Then there's the mean. Well, the new mean now would be the new mean would be $166,000 and change. So I'm going to call it 167K. Okay, just to sort of save space. But clearly we can see that we went from a mean of 32.4K all the way to 167K. That's a big change. So you can see that the presence of this person who makes $1 million a year pulled the mean, annual salary up a lot, right? So that's that. The median, well, the median used to be 32K. That was the middle number in the data set before. And the median is a little bit different now because we had 5 people before, but now we have 6. And whenever you have an even amount of people, you then have to consider the middle two numbers when you're calculating the median. You're going to take the average of these two numbers. And the new median is going to be 32.5K. So if you found the average of 32K and 34K, you would soon discover that it's 32.5K. And that's not that much different than 32K. So I would say the median change is definitely pretty small. Definitely pretty small. So that leaves the standard deviation, and the standard deviation is how tightly clustered around the mean the data is. Well, the standard deviation was pretty tight before, where it's like, 32.4K was the old mean, and all of these numbers are pretty tightly packed around that mean of 32.4. Okay, so the standard deviation used to be relatively small, but now the standard deviation is a lot larger because you have the mean um, at 167K because this new person came in. So you can imagine the data is now really a lot more spread out because, we have the original two or the original 5 people down here at 32K. And let's imagine, we're really going to have to zoom out. Let's imagine we have the million person over here. So that's a million. Imagine this is like $1 million. This is 32K dollars around that range. Well, the mean of 167K dollars, that's like around here. That would be the mean of 167K. I think you kind of get the idea. It's like around here somewhere. And that's a pretty big spread. I mean, here's the mean, and these guys are kind of far away from that. And this $1 million person is pretty far away from the mean. So the spread just got really big as a result of the new person walking in the store. Okay. So sometimes to actually consider what the actual values are, maybe even consider where they would fall on a number line. That's a decent way of going about it. That's kind of what I'm doing right now. And just ask yourself, okay, well, where's the mean, in the midst of all this stuff, and how far away is everything from the mean? That'll give you a sense of the standard deviation. Now, do you have to always draw it like that? Not necessarily. I mean, at a certain level of practice, you're going to be able to get a flash of that kind of an image in your head, and you'll quickly see just logically it makes sense the standard deviation would drastically increase in this circumstance. So the question has to do with which statistic did not change that much. And I think we can all agree it was the median. The median really didn't change that much. Everything else changed a lot, but the median hardly changed at all. It only went up, by 500 units, at least according to our data. There's no way the median is going to go up by any more than 5,000 units in this particular situation, because all that's going to happen once you introduce a sixth person is it's going to go from the third data to the fourth to the average of the third and fourth, and that was all within a 5,000 unit range. Okay, so the median will not change more than 5,000 units. So that certainly changes the least. Hopefully that makes sense, and that is exactly why the answer to this problem is C. Problem number 40 is a little bit of a tricky work problem, and the formula that you're going to want to use for work problems, at least one of the formulas, is rate times time equals work. And if it's one job that you're um, taking interest in, then it's going to be, rate times time equals 1. Okay, one job. Now this one over here might be represented as 12 over 12 or 30 over 30. You might have to mess with this one in the midst of the problem to make it something workable. However, just know that if it's one job, that's all you're really worried about is this being one. And clearly we could see, since the problem is asking which of the following values is closest to the number of hours it would have taken one of them to complete the entire job alone, um, we want to solve for t, but we need to find the rate at which one worker works. Okay, so we need to find out how fast the worker is moving, what rate are they working, and then once we have this number, we could easily solve for t. So really our goal is to figure out, okay, well, what is the rate by which a worker works in this scenario? So as you would expect, they do give us clues. So let's look at what they say. So Anna completed 2/5 of a job. Amy completed 1/3 of a job. Now they did work together, but if we want to get a sense of how much of the job is now complete after these people worked on the job, well, you just add 2/5 plus 1/3, and you would soon find that that is indeed, looks like it's going to be 11/15 of the job. Okay, so Anna completed this amount, Amy completed this amount, so we know that thus far 11/15 of the job have been completed. Now, if you want to know how much is left over, well, you just subtract 11/15 from the entire job, which is, 15 over 15. And then we subtract 11 over 15, and that gives us 4 over 15. So there's 4/15 of the job left. Now apparently Ruben completed the rest of the job in 2 hours. So Ruben completed this. Ruben completed 4/15 of the job, and it took Ruben 2 hours. So that's the first moment in this problem where we can get a sense of what the rate is. And apparently the rate, um, by which all three of these people work are the same, because in the problem they say, assume that Anna, Amy, and Ruben all worked at the same rate. So if we could just find out Ruben's rate, then we have everybody's rate. And then we have the rate that we need to solve the problem. So we need to figure out, okay, well, if it took Ruben um, 2 hours to do this, well, how much work could Ruben do in 1 hour? And that would give us the rate. Okay, so let's put work over hours, and we're going to investigate it with a proportion. So apparently, 4/15ths of the job can get completed in 2 hours. Put this in parentheses, and we can set that equal to x over 1, because we know that Ruben completed 4/15ths of the job in 2 hours. So how much would Ruben have completed in 1 hour? Pretty straightforward. Now, some of you might even be able to do this in your head. You can kind of see what's going on. But let's say it's not obvious to you and you just want to use the proportion. So it's 4/15ths times 1, because that's cross multiplication. We're going to have 4 over 15. And then we have that equaling 2x. And at that point, we do need to divide both sides by 2. And when you divide a fraction by a number, by a whole number, really the number that you're dividing by gets multiplied to the denominator. So these cancel, and then you end up with x equals 4 over 30. And that is most definitely a fraction that can be reduced. That would reduce and turn into 2 over 15. Okay, so that is the rate that we are looking for. We just, again, reasoned out if a worker can finish 4/15ths of a job in 2 hours, well, how much will they do in 1 hour? We cross multiplied. We did a little bit of tricky division, and then we realized that these workers can perform 2/15ths of a job in 1 hour. That's what we just discovered. We now have our rate. So what I'm going to do is just transfer this over here. And instead of writing r times t equals 1, I'm actually going to go ahead and just write 2 over 15 times t equals 1. And then we're going to solve this. Now, you might be wondering, okay, well, how do I solve for t? There's a big ugly fraction in front of it. Well, it's actually not that bad. Whenever you have a fraction coefficient in front of the variable that you're trying to solve for, and you're on that last step in particular, just multiply both sides by the reciprocal. Okay, multiplying both sides by the reciprocal, and these would cancel. That's in fact the whole point. And then we have t equals, and 1 times 15 over 2. Well, that's 15 over 2. And that turns out to be 7.5. And that is exactly why the answer is K. So the takeaway is to use this formula, realize that 1 equals 1 job in this context. Realize that each person, like Anna, performed 2/5 of a job. Amy performed 1/3. Therefore, that's a total of 11/15ths of the job completed. Even though they worked at the same time, they completed different parts of the job, right? So 11/15ths of the job were completed, and therefore there were 4/15ths of the job left. That was taken care of by Ruben. Ruben took 2 hours to do that, so therefore it takes he would hypothetically complete 2/15ths of a job in 1 hour, which by the way is half that. Okay, so for those of you who did it in your head, that's how you could do it. You could realize, okay, it takes 2 hours to do this. Well, in half the time he would have been able to perform, to finish half of this, right? So 2/15ths can be performed in 1 hour, and then now you know what your rate is. That's your unit rate, and then you put that in to this equation and solve for t if you want to know how long it would take one person to complete one entire job. Okay, so problem number 41 is a nightmare, especially if you're not really used to the laws of exponents and so on and so forth. So A few things right out the gate. So I'm going to present to you a few principles before I dive into this particular problem. It looks to me like the principles you need to know are the following. Number one, imagine you have a times b raised to the second power. Well, there's a law of exponents that says that when you have a product raised to an exponent, that exponent gets applied to both of the numbers. Okay, now that's not when you add a plus b, that's when you multiply a plus b. So then you end up with a squared times b squared. Okay, so that is a principle that you need to know. Another principle you need to know is anytime you have um, two variables raised to a certain exponent, and you're multiplying these two together, and the exponents, maybe they're different, maybe they're the same, but anytime you have the same variable with exponents, you're multiplying them, you keep the variable and you add the exponent, so that becomes this. Okay, another thing you need to know is that anytime you're taking the square root of a number, like x or something, that could be rewritten as x to the 1/2 power, and vice versa. So if you have a 1/2 as the exponent, you can think of it as the square root of x in that case. All right, so everything that I am showing you, probably more often than not, you're going to be moving from left to right, but just know that from right to left could exist as well. There are certain times where maybe you might want to break up x to the fifth into x to the third times x squared. Okay, there might be some moments. Another thing you definitely need to know is anytime you have a negative exponent, you bring it to the opposite floor that it's already on. You can always think that all numbers are secretly in a two-story building. In this case, you have an invisible 1 underneath x to the negative third. So what happens is you could rewrite that as 1 over x to the third, but you're going to want to switch the exponent into a positive 3 as opposed to a negative 3. Now, that also pertains to situations where you already have a variable that has a negative exponent in the denominator. Well, now it goes up to the top floor, okay? So you can think of it as x to the 10 now. Okay, now it's the case that you're going to want to just leave it like that, but you can know in your head that there is indeed an invisible 1 underneath there. And the reason I'm focusing on putting that invisible 1 during this demonstration is just to show you that it's temporarily useful to think of this as a two-story building, and then anytime you see that negative exponent, you just bring it to the floor, that it's not already on, whether it's the bottom floor in this case, or taking it from the bottom floor and bringing it up to the top floor. Now, that could be an interesting situation when you have things happening, for example, like maybe you might have 3x to the third all over x to the negative 2. Well, the rule that I just denoted says that this x to the negative 2 could now be brought up to the top floor, and therefore it becomes 3x to the third times x squared. And according to this law right here, I can write that as 3x. Adding the exponents would give us x to the fifth, and that would be a way of simplifying this one. Now, there's another law that you're going to need to know in order to solve this particular problem, and that is when you are raising a power to another power. So what I mean by that is if I have x to the fourth and that's being raised to the second, well, before we even move on from here, let's just be clear. This is not the same situation as this. This is x to the third times x to the second. This is x to the fourth raised to the second power, right? So it's we're raising a power to another power. When that's the case, you keep the base and multiply the exponents. So that becomes x to the 8th. And unfortunately, I'm also seeing there is another thing that we need to talk about, and that is the fact that anytime you have an exponent over a variable like that, and it's in the numerator, and the same variables down below, regardless of whether it's positive or negative, you can also rewrite that as keeping the base and subtracting the bottom exponent from the top exponent, and that ends up becoming a to the first power. Typically, we don't need to write that exponent of 1. This is really just a. So what we're going to do is keep these laws available to us. That way we can refer to them if need be, and we will be tackling the problem now. The problem is 2a to the negative 1 times radical b, and that whole quantity is raised to the 4th, and that is all over a times b to the negative 3. Now, before you begin the simplification process, or we could say at the beginning of the simplification process, you need to ask yourself, is the numerator as simplified as it could be? Is the denominator as simplified as it could be? Because let's just simplify each of these separately and then do any kind of combination or whatever you have to do after that. So the first question is this as simplified as it could be? Well, it's not, because I could apply this law right here, which would apply the exponent to all three of those numbers. And that's what we're going to want to do. Now, before we do that, let's be very clear. This radical b, due to this law right here, that could be rewritten as b to the 1/2. So that's exactly what I'm going to do. I'm going to write b to the 1/2. And now I feel more comfortable going ahead and distributing that exponent, or I should really say applying the exponent to each of these three numbers. And what I'm going to do is write each of the three numbers inside parentheses. The first one is 2, and that's going to be raised to the 4th power. The next one is a to the negative 1. That's going to be raised to the 4th power. The next one is b to the 1/2. That's going to be raised to the 4th power. And we still have this a times b to the negative 3, which we'll deal with later. So at this point, we can get clear on the fact that 2 to the 4th is 16. We can then realize that this is a power raised to another power. That's this law, power raised to another power. So that's going to become a to the negative 4. This one is b to the 1/2 raised to the 4th. Now, what is 1/2 times 4? What is that? That's 2. So that's going to be b squared, and that's all over a times b to the negative 3. Now, let's be clear about what's happening here. Now we're ready to actually apply this whole law. Anytime you have like over like, you can keep the base and subtract the exponents. Well, we have a like over like scenario here. We have another one here. Now, what I like to do, and this is just me, I'm really big on staying as organized as I possibly can as I proceed through these kinds of problems in particular. And the truth of the matter is, we have three different kinds of characters. We have a 16, that's a certain kind of character. We have a base of A and a base of B. That's three different kinds of characters. So I'm actually going to draw 3 parentheses, and we're going to consider each character separately. So the first character is 16. I'm just going to go ahead and write that. That's 16. You could also think of it as 16 over 1. We might want to think of it as 16 over 1 soon, but let's just kind of see what happens here. Over here we have a to the negative 4th over a to the 1st power. The truth is that there's this invisible exponent of 1 hovering above that a. And what do we say about when we have like over like? When we have like over like this, we keep the base and we subtract the bottom exponent from the top exponent. Well, that's what we're going to do here. We're going to keep the base and we're going to subtract 1 from negative 4. So that's going to become negative 4 minus 1. Over here, we're going to keep the base, right? Keep the base and subtract the bottom exponent from the top exponent. So that's going to be 2 minus -3. Notice how I have to be super careful with the fact that I'm subtracting a -3. That's why I put it in this little parentheses here to be very clear to myself that I am now subtracting a negative number. Had I not written these little tiny parentheses, the negative symbols might have blended into each other, and I might have made the mistake of just thinking of it as 2 minus 3. But it's not 2 minus 3, it's 2 minus -3. So you do have to be very careful with that kind of stuff. You can really never have too many parentheses, okay, to keep things separated, keep things compartmentalized. Now, I understand this is a tedious process, but we will continue to simplify it. Go ahead, draw the parentheses again. 16 is minding its own business. -4 minus 1 is -5, so that's going to become a to the -5th. Then we have 2 minus -3. That's really 2 plus 3, so that's going to be b plus 5, or b to the 5th power, rather. Okay, so now we have a string of 3 numbers. The truth of the matter is that this one could hypothetically be rewritten as 1 over a to the 5th. So when you kind of do your final move, which is coming up soon, you're going to want to at least consider turning everything into a fraction and then multiplying the fraction straight across. So we're going to turn each of these into a fraction. So 16 is secretly 16 over 1. Now let's be clear, this one is 1 over a to the 5th. 1 over a to the 5th. This one right here is b to the 5th over 1. And then what you now have officially are 3 fractions, and you can multiply straight across. So that's how I would do it. I would keep everything super organized, 16 times b to the 5th all over a to the 5th. Now, as you get proficient at all this stuff, you're going to get to a level of skill where maybe you don't need to do all this compartmentalization and et cetera, et cetera. But if you're not that well practiced at it, trust me, separate things out. Be very meticulous, focus on one thing at a time. That's also a way of avoiding getting overwhelmed, because when you separate it, it's like all you have to deal with on the next line is, okay, well, what happens to the 16? Focus there. Okay, when it comes to this next one, what happens here? Focus there. Focus only on that. And then for this one, focus on, okay, well, what do I have to do with that one? And then bring it down there. Very systematic. Anyway, I think you get the idea. Once again, simplify the numerator first. If there's an opportunity to simplify the denominator, like apply exponents in a similar fashion, go ahead and do that. We went through the process of simplifying it. Then we stacked like over like, separated into 3 different kinds of characters that we have to deal with. And then we kept things compartmentalized. And then before the final move, we kept it compartmentalized, but we turned it temporarily into fractions. That way we could easily just multiply straight across and very easily see what the answer is. So the answer is obviously, as a result of everything I said, the answer is C. Problem number 42 relies on your ability to at least have a basic understanding of permutations. And a permutation is basically a way of finding out how many different ways you can order a list of objects or data just in general. And, when it comes to the Rockstar situation, okay, let's imagine that you have Rockstar A, B, C, and D. And according to the problem, you already know, or the person already knows who's the oldest. So let's just imagine that D is the oldest, right? So whenever you're listing the rock stars by age from youngest to oldest, you will end up having D over here. You're going to end up having D right there, always, no matter what. So this position here does not change. It's this that changes. So the question is, how many different ways are there to order A, B, and C? Okay, how many different ways are there to order A, B, and C? Now the tedious way is to actually list them all, right? So again, we're not really worried about D. We're only going to concern ourselves with A, B, and C. So just off to the side, you could be like, okay, well, one way to order them is ABC, another one is CBA, another one is BAC, et cetera, et cetera. But this is relatively tedious, whereas what you might want to do is instead just use a permutation, and that would be to recognize that there's really three characters, and then you just kind of think one at a time. Let's say you're choosing the first character. How many different characters do you have to choose from in that moment? Well, you have three. You have three characters to choose from. Now, once you've chosen a character for this position, how many characters do you have left? Well, you have two. And then you have one left after that. And all you have to do is multiply these. And you would quickly see that there are six different possible orderings for these. Now, could I have listed them out? Yeah, I mean, there's only six, right? But if you understand permutations, you could save yourself all that time, and then you could realize that only one of the sixth is the correct ordering. Let's say that it turns out to be CBA. So that's one out of six possible different orderings, and therefore this is the proper order. And had you guessed this portion, it would have been a 1 out of 6 chance that you would have guessed these three correctly, because there's only 1 out of 6 possible orderings. So therefore the probability of guessing these three correctly is 1/6, and that is answer choice G. Problem number 43 presents you with a specific subspecies of algebra problem that comes up a lot on the ACT, and that is when you have sort of fractions within fractions and a big mess, what we would consider to be a big mess. And this is a big mess, all right? They want you to simplify this. Now, you look at the answer choices and you see all kinds of stuff, and it's like, oh my God, how do they possibly get from here to the answer choice? Well, basically, all you have to do when you're contending with fractions within fractions, at least what you might want to strongly consider is figuring out what is the least common denominator of these denominators here. Or you could think of it as, okay, I've got 4 different denominators. What is the least common multiple of these numbers? We have 3, 2, 3, and 4. So the least common multiple is clearly 12. Okay, 12. So what we're going to do is multiply the top by 12 and the bottom by 12. And you're going to be very pleased to see what happens as a result. Now, when you multiply the top by 12, you're going to have to distribute the 12 here and here. Same thing with the bottom, okay? Now, I'm actually going to write this in a way that looks a little different, but sort of highlights what's happening. So we have x over 3 plus 1/2, and then we have 2/3 minus 1/4. Now, sometimes I've seen some teachers, they like to just hover the 12 over as though it's this vulture circling its soon to be prey. And then I'll put an asterisk sort of highlighting the fact that we are indeed multiplying each of these by 12. Now, what happens here when you multiply 12 times x over 3? Well, the 12 would turn into a 4, and this would cancel, okay? When you multiply 12 times 1/2, well, in that case, the 12 would turn into a 6, and this 1 would cancel. When you multiply 12 times 2/3, the 12 would turn into a 4, and that would turn into a 1. And similarly, over here, the 12 would turn into a 3, and the 4 would turn into a 1. So we are indeed getting closer to our answer. Focusing here, what's left over? So you have to be pretty meticulous with how you cancel stuff. What's left over is 4 times this x, and that's over 1, but we don't have to write this 1 down below, okay? So it's 4 times x up top, And then we have 6 times this 1, so it's 4x plus 6. And then that's going to be over. And then we have this 4 times this 2, which is 8. We don't really need to write the denominator of 1 because 1 is secretly underneath every number. So this is going to be 4 times 2, which is 8. And then over here we have 3 times 1, which is 3. Now this is a subtraction situation, so that's going to be minus 3. And writing it again gives us 4x plus 6 all over 5. And that is answer choice D. So the moral of the story is when you're presented with fractions over fractions, strongly consider the possibility that it might be beneficial to come up with the LCM, the least common multiple of all the denominators. Sometimes that's called the least common denominator, and literally multiply the top and bottom by that actual number. So the least common multiple of these 4 numbers was 12, so we multiply the top and bottom by 12. Now it's okay to do that, as many of you know. You're allowed to multiply the top and bottom by 12 because 12 over 12 is secretly 1, so we're not changing the value of anything. This is literally the exact same value as the original thing, it just looks different. That's all. So yeah, D is the answer. Problem number 44 features the fundamental counting principle, and the fundamental counting principle, in my opinion, is best used with underlines. So the license plates have 6 underlines, okay? And each of these represents character positions. So the first 3 are 0 through 9, and the last 3 happen to be any of the 26 letters. Okay, so any of the 26 letters. Okay, so what we have to do is just focus on each space one at a time and ask yourself, how many possibilities are there for this character? Now, how many possibilities are there for the first character? Well, if we're choosing from 0 through 9, you want to be really careful. There's 10 possibilities there because think about it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, but then 0 is one of them as well. That's the 10th possibility. You could think of it that way. So there's 10 possibilities here. Let's just confirm, can the first character be 0? These are the first 3 positions, 0 through 9. Yeah, so interestingly, the first character can be 0. You do want to be on the lookout for problems where they're like, the first character can't be 0, but everything else can. Well, if that's the case, then this would be 9, and this would be 10, this would be 10. But for the same reason that this is 10, as it pertains to our problem, this is 10, and this is 10. And I think most of you could probably see what's going to happen with this. That's going to be 26 and 26 and 26. Okay, 26 possibilities for this position, 26 possibilities for this position, and so on. Then all you have to do is just multiply all the way across. And that's all you have to do. Now, if you're wondering what the final answer is going to be, if you want a shortcut, well, first of all, of course, you can use a calculator. But if you want to get fancy, you're going to realize that this is 1,000. So it's going to be 1,000 times whatever the heck this is. So there's going to be at least 3 zeros at the tail end of the answer, which means that H and K are the only contenders. Okay? H and K are the only contenders. Now K is looking suspicious because what are the chances that after multiplying 1,000 times this, you're going to get 1 million on the nose? I'm going to say no. In fact, I am so confident right now that K is the answer. You could verify that if you want with your calculator, but we know that there's going to be at least 3 zeros on the tail end of this, and the chances of it being literally 1 million, given the fact that you have these, is very small. So I would say answer choice H is gone. But let's say it wasn't that obvious. Well, one thing you could also do is you could track the units digits You know that when you multiply 26 times 26, well, this 6 times 6 is going to give you a 36, right? So that's going to give you another 6 in the units digits place, and then a 6 times this in the units digits place is going to give you another 6 in the units digits place, which means that answer choice K is most definitely the answer, because after the 3 zeros, or we could say before the 3 zeros, there is a 6. So that is K. Now, if you hate everything I just said, if you didn't follow that at all, um, actually, I don't blame you because I just kind of thought out loud. At the end of the day, set up the fundamental counting principle and then just plug it into your calculator if you want to avoid confusion. But if you want a shortcut, you would realize there's 3 zeros at the end, and you would realize that the digit that's right before the 3 zeros is going to be a 6. So anyway, that's how you do problem 44. So problem 45 tests your ability to recognize what transformations are on functions. So for example, let's say I have a function f of x, and that could be on a graph like this, and it's just a parabola like that. Well, that's f of x. Let's say that's f of x. But the moment you apply a transformation such as adding plus 2 or something, well, that plus 2 on the outside of the parentheses would shift it up 2, okay? That would shift it, vertically shift it up 2, okay? If it was f of x minus 1, well, that would vertically shift the parent function down 1 unit, okay? So the parent function is the black function. The black function used to be the original function. Well, when I put this -1 or -1 next to the f of x, that's a vertical shift downward 2 units, or 1 unit, I should say, and it turns into that. So those are vertical shifts. Now, horizontal shifts are a little different. So imagine I had this function here. Once again, that's f of x, and then I apply a horizontal shift. Now, a horizontal shift takes place inside the parentheses. So imagine we had f of x, and then I write plus 2 right there. So it's basically the old function, only plus 2 inside the parentheses. Now that's a horizontal shift 2 units to the left. So as you might see already, when it comes to vertical shifts, it says plus 2. That means it goes up 2. I would say that's pretty intuitive. When it says it's -1, that means it goes down 1. That's pretty intuitive. That's pretty straightforward. So when it comes to vertical shifts, or even vertical anything, when it comes to transformations, vertical stuff is intuitive. It's the horizontal stuff that's always kind of the opposite of what you would think. So when you say plus 2, it really means it's going over to the left 2. All right. So as long as you can remember that horizontal transformations are typically the opposite of what one might assume, you should be good to go. Now, as it pertains to our particular problem, um, we had a function of f of x that was the original, but then it turned into y equals, what is it, 3 plus f of x minus 1. Now they're being annoying by writing the 3 first. Typically, this would be written after. So I'm actually going to do that just to make it a little bit more familiar looking to us, because the truth is that adding of 3 to the function on the outside of the parentheses, well, that is a vertical shift upward of 3 units in the same way that I had mentioned before. Okay, so what we're dealing with when it comes to this transformation from the original function is a vertical shift upward 3 units and a horizontal shift to the right 1 unit, because once again, it says -1, so that's going to be the opposite of what you would think. So another way of saying it is that it's a horizontal shift 1 unit to the right and a vertical shift 3 units up. And that is answer choice A. So all that's required is don't get intimidated by the graph. Don't worry about the squiggly line graph. All you need to know are the principles of transformations of functions. That's something easily found on YouTube, but vertical shift and horizontal shift are pretty straightforward. Problem 46 obviously is testing your ability to navigate logarithms. and to sort of understand what they even mean by log sub 5x equals -2. Well, the trick here is to develop the skill of converting logarithmic equations into the exponent form. And that's not that hard once you get the hang of it. The first thing that I think is worth noting is that you have a little 5 down here in the bottom. It's kind of underneath. And that's called the base. Now, when you think about the word base, that hopefully makes you think of that which is underneath. The base is that which is on the bottom, that which is underneath. Now, one good rule of thumb to remember for logarithms is that the base remains the base. So it's going to be a base of 5 with something over it, namely an exponent. Okay, and that exponent is going to be the -2 that is across the way, and that's going to equal x, which is right here. So it's this kind of, you start with the base, and then you cut across, and then you go across again. So it cuts up to the right and then over. So if you can remember that move, you're going to be fine. So it's 5 to the -2 equals x. Okay, so if you just remember that. And then we need to remember that anytime you have a negative exponent, well, you can just rewrite that as 1 over 5 to the +2 in this case. And 5 to the +2 is 25. So it's really 1 over 25. And that is the answer to that one. That is K. With problem number 47, I would suggest giving yourself a visual representation of what's happening. We have 2 over D, and we want that to be in between 1/5 and 1/3. Now 1/5 is less than 1/3, so we're going to put it there. And we have 1/3 there. Now, I would strongly recommend for problems like these where you're comparing fractions to convert them to decimals. That's going to make your life a little bit easier. So this is really 0.2. Now we don't know what the middle one is because we don't know what D is. And this over here is 0.3 repeating. And then at that point, it's really going to be a matter of just plugging in the answer choices in for D and then finding out what this decimal is and seeing if it's indeed between 0.2 and 0.33. Repeating, so that's the short version of how to go about this problem. However, let's take a look at the answer choices because there is a little bit of strategy that you could use featuring the process of elimination. So this one says 4 only. This one says 3, 4, and 5. This one says 8 only. This one says 7, 8, and 9. And this says 16 only. Now I'm going to describe a strategy for those students who really want to shave off time and use the process of elimination maximally and optimally. Bottom line is you should test the number answer choice A first because it says 4. Now, if 4 works, then these are gone. Okay, so if 4 works, then these are definitely gone. Because if 4 works, then we've narrowed it down to answer choice A or B. If 4 does not work, then answer choice A and B are gone because answer choice B has 4 in it. So if 4 does not work, then we have to get rid of both of these. Once you test out 4, and let's say it doesn't work, then you should definitely try answer choice C for a similar reason because you're going to get a lot of information from it. Let's say you try answer choice C and it works. Well, that means you could then get rid of answer choice E because E says 16 only. And it has been narrowed down to answer choice C and D. Okay. Now, if answer choice C does not work, then you have to eliminate answer choice C and D, and then you know for a fact that answer choice E is the answer by process of elimination. Now, if that's not your thing, approaching it in that strategic way, don't worry about it. You just go ahead, plug everything in, see what works, see what doesn't, and so on. Okay. Now, starting with checking out answer choice A, which is the number 4. When you plug 4 in here, it becomes 2 over 4. That becomes 1/2. 1/2 is 0.5. So that would be 0.5. Now, 0.5 is not less than 0.33. Repeating, so therefore both of these are gone. Since 4 did not work, that means this 4 isn't going to work either, so they are both gone. So then you could try answer choice C, which says 8. Now, if that was an 8, it would be 2 over 8, and 2 over 8 is 1/4, right? So that's 1/4, and as a decimal, that would be 0.25. Now, 0.25 could work, right? 0.25 could work, so therefore we can now get rid of this one because 0.25 is certainly larger than 0.2, 0.25 is certainly less than 0.33. We just discovered that 8 works, so therefore this thing that says 16 only, that's incorrect. Now the only question is it answer choice C or answer choice D? Well, with the answer choice D, all you have to do is really focus on just either 7 or 9, just picking 7. Let's just start there. If 7 works, then we're done. The correct answer is answer choice D, because if 7 works, then this whole idea about 8 only, like that's not true because 7 just worked, right? So in other words, we don't have to check out whether or not 9 works. As long as 7 works, we're finished. So we will test it. 2 over 7. What is 2 over 7? Let me check in my calculator right now. 2 over 7 is 0.28571 blah, 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 blah. 0.28 something. So that would work, right? Because we have 0.2, we have 0.33. Repeating, 0.28 is indeed in between those two. So therefore, this is gone, and D is the answer. Problem 48 is a good problem to use your own numbers. So anytime you see variables in the question itself and variables in the answer choices, that could be a sign that plugging in your own numbers would be helpful. Now, when you're plugging in your own numbers, you might want to stay away from numbers like 0, 1, and I would even say 2. Stay away from 2 as well. You're going to want to stick with maybe more like weird and or extreme numbers. So let's just say that A is greater than B. So A, let's say, is 100. Let's say that B is 20. And C is apparently less than 0. So we'll say that C is negative, negative 10. Okay. And let's test it out. Now, obviously, the question is saying which of the following inequalities must be true. Well, the word must is pretty strong. We could at least start by figuring out what's definitely not true and just eliminating answer choices, okay? And that will get us closer to perhaps understanding what must be true. So looking at answer choice F would have us put A over C, which is 100 over negative 10, and that would be less than B over C, which is 20 over negative 10. Now, this would be negative 10, and this would be negative 2. That actually works, okay? Because negative 10 is less than negative 2, if you think about it on a number line, okay? So answer choice F is a major contender. Then we have G. So G says A over C, which is going to be 100 over, well, you know what? We don't even need to do G because G is the exact same thing as this, only it's greater than. And we know that that's not true, right? So answer choice G is gone because G is a replica of this, only the inequality symbol is flipped, and that would lead to something that is untrue. Let's look at answer choice H. Now, answer choice H says A times C, that's 100 times negative 10. And they're basically saying that that is greater than B times c, which is 20 times negative 10. Well, this right here would be negative 1,000. This right here would be negative 200. And it is not true that negative 1,000 is greater than negative 200. The opposite is true. Negative 200 is actually greater than negative 1,000. So this one is also gone. So at that point, we are looking at answer choice J. Answer choice J has A plus C, that is 100 plus negative 10. And apparently they say that is less than answer choice or B plus C, which is 20 plus negative 10. So we're going to look at it. 100 plus negative 10 is 90. And is it the case that 90 is less than, this is 10, right? So that is incorrect. It is not true that 90 is less than 10 because 20 plus negative 10 is 10. So that is gone. And I'll tell you, this answer choice F is looking pretty good. All right, we're down to K at this point, and we have A, which is 100, is apparently less than B minus C. Well, B is 20 minus C, which is minus negative 10. Now, some of you can already see that is not going to work because 100 is not less than 30, okay? So that's gone as well. That leaves us with answer choice F. Now, again, if you're going to use your own numbers, stay away from 0, 1, and even 2. I would also say if they tell you something like this problem, one of the things this problem said is that A is greater than B. You want to kind of choose numbers that exacerbate that fact, okay? So in other words, I'm going to choose an A that's a lot bigger than B. So we're kind of exaggerating this relationship, and that tends to be helpful. That tends to be really helpful when it comes to eliminating stuff, okay? We're making things very black and white. You know, if A is going to be greater than B, it's going to be a lot greater than B. And then when you plug it in, you get these, you know, the exaggerated relationship weeds out all the sneaky ones, okay, that are wrong. So we were left with F. All right, so that's how you do 48. Problem 49 might be the most difficult, or at least intimidating problem on this entire practice test. And therefore, the first step is to just take a deep breath and trust the test makers, which maybe you don't feel like doing, but you trust the test makers that they actually did give you enough information as long as you calmly look at what they're saying. Now, the first thing they're saying is that there's a triangle. And not only is there a triangle, but there is a triangle that looks decent. And this is 38, and this is 39, and this is 37. Now notice how they did not label the vertices, okay? So we might have to label the vertices. Then they go ahead and they give you, this is called the law of cosines, okay? So they say c squared equals a squared plus b squared minus 2ab cosine C. Now, I'm making this C extra large because I want to really make sure it's clear that this is a capital C, this is a lowercase c, it's lowercase a, lowercase b, and so on. Okay, and we're going to get to that in a moment. All right, so we're going to put this on pause, and I do want to highlight something that will come into play in this problem. It's often the case that they will give you problems featuring cosine. Maybe you got to find cosine of 45 degrees, and then you would be like, okay, that is this. You know, you might even memorize that or something, but they'll usually give you the angle. Okay, they'll give you the angle, and then maybe you could plug it into your calculator and be like, okay, cosine 45, and then it gives you a number. Or there are various ways of remembering certain sort of famous degree measurements and the cosine and the sine and all that stuff. But my point with that is usually they'll give you the angle and then you take it from there. But every now and then the angle itself is going to be unknown. So for example, what if they say the cosine of some angle equals 1/5, and then your challenge is to find out what that angle is? Well, what you're typically going to want to do in that case when the angle is unknown is do what's called the inverse cosine. Okay, it's the inverse cosine. Some teachers might call it the arc cosine, but that ends up being a way of solving for the angle. Okay, now before I even say more, I just wrote this. This is not multiplication. This is not cosine times some angle. So it's not like we're dividing both sides by the word cos, right? We're not doing that. This is a number in and of itself. But what we are doing is we are liberating the angle from a certain point of view. And what it becomes is the inverse cosine of 1/5. Now, we have, in a sense, just took a big step towards solving for this angle because this is something that you actually can plug into your calculator. So if you ever had a problem that said the cosine of what angle equals 1/5, well, all you have to do is take the inverse cosine of 1/5, and that will give you the angle. And you could put this in your calculator. Okay, so when the angle is unknown and it's the cosine of that angle and you want to find that angle, you use inverse cosine. Now to be clear, this -1 is not an exponent. It looks like an exponent, but it's actually not. This is just sort of a notation that lets you know that you're using the inverse trig function. Now let's get to this law of cosines equation. This big C represents the angle you're focusing on, okay, in the triangle. The big C represents the angle you're focusing on. And these little lowercase letters represent side lengths. Now, I say we get clear on what is the angle we're focusing on. Well, according to the problem, they're curious about which of the following expression gives the measure of the largest angle of the triangle. The largest angle of the triangle. Well, what is the largest angle of this triangle? Well, I know the largest angle is this angle. And the reason I know that is because this is the angle that's across from the longest side. So you know this is the largest angle. It's almost as though this is like a spotlight that opens up to a certain degree measurement and it shines a spotlight on the wall. This is like the size of the spotlight. And it makes sense that the bigger this angle gets, the larger the spotlight will become on the wall. Similarly, we know the smallest angle in this triangle is this one because it's the one that's across from the shortest side length. Now, what we have just discovered is that this is the angle we're focusing on. Now, I had told you before, what is big C? Big C is the angle you're focusing on. So now we're going to therefore force this to be angle C. Okay, and then we have angle A and angle B. All right, clockwise. Okay, now some of you might be wondering, well, what if I did B and A? Would that change things? And actually, it wouldn't. Okay, but when in doubt, go clockwise. Now, you might be wondering, what are these little lowercase letters? What do they mean? Well, like I said before, they are side lengths, but specifically, let's focus on lowercase c. Lowercase c is this one because this is the side length that's across from the big C angle. Similarly, this 37 is equal to lowercase a, and that 38 is equal to lowercase b. Once you've properly labeled the triangle, you're then on your way to just plug in all of that information into the equation. So we have c squared, that's really 39 squared, That equals a squared, which is 37 squared, plus b squared, which is 38 squared, minus 2 times, I'll use parentheses for this part, 37 times b, which is 38, times cosine c. Now, let's be very clear. This, again, is a number. It's not cosine times c. This in and of itself is a number. So in reality, this is a string of 4 numbers being multiplied together. You have negative 2 times 37 times 38 times cosine c. One thing worth mentioning at this point is you might be watching the video and feeling tempted to square these, okay? Because you learned that. That's PEMDAS, actually. Please excuse my dear Aunt Sally. You're supposed to apply the exponents and this and that. But if you look at the answer choices for this ACT math problem, you will see that these, squared numbers are featured in the answer choices. So it turns out we don't have to square them, and I would say that that's a good thing because you would end up with really big, clunky numbers that you're not going to want to deal with. Now, at the end of the day, they're asking which of the following expression gives the measure of the largest angle of the triangle. So really, what we're doing is we're trying to get C by itself with some expression over here. We're trying to get the angle C. In fact, I'll make this in red too. We're trying to get that by itself with some other thing over here, and whatever this expression is, that's going to be the answer. So the task is to get this C by itself. Now I'm going to make some room. And when you look at this equation, hopefully one of the things that stands out is that you are going to want to at least get this term by itself, because this is the term that has cosine C in it, and that would sort of get us one step closer to isolating C. So we're going to have to get rid of this stuff right here. So we're going to have to get rid of the 37 squared. So we'll subtract that and the 38 squared. And of course, we have to do that from both sides, right? So we have to go minus 37 squared minus 38 squared. That would cancel these. And then we are left with 39 squared minus 37 squared minus 38 squared equals this negative 2 times 37 times 38 cosine C, and I'll keep that big C in red. Now, again, we are attempting to get C by itself. We are hopefully remembering that cosine C is a number. This is not multiplication. This is a number that is thus far untouchable. You can't tamper with it. But what you can do is you can get closer to isolating C by at the very least isolating cosine C. That would bring us closer. And the way to isolate cosine C is to get rid of these 3 numbers there. So we would divide both sides of the equation by those 3 numbers. Now, once again, if you look at the answer choices, you will see that maybe they did something like this, because you see a lot of the numbers separated out in the final answer. So it's a sign that it's okay to leave things separated out. So then we have cosine C finally by itself. I'll keep it in red with the C, and that's equal to, put a little line here, that's equal to 39 squared minus 37 squared minus 38 squared all over negative 2 times 37 times 38. And we have gotten very far. We've gotten very close to isolating this angle C. And that's where this thing comes in. Do you remember how I said, oh, if the angle is unknown, you can solve for the angle by doing the arc cosine or the inverse cosine of the other side? Well, that's what we're going to do. We're going to get C alone. We're going to get C alone by taking the inverse cosine of the other stuff. Okay, so that looks something like C being by itself equals inverse cosine, again with the divider, it's going to be inverse cosine of all that stuff on the previous line. Okay, 8 squared all over negative 2 times 37 times 38. And I'll space things out a little better. I think everyone probably gets the idea, though. And congratulations to me for doing this, and to you for understanding it. This is the answer. That's the angle. When you plug everything into that formula, you can find an expression, thusly, that corresponds with that angle. So hopefully that makes sense. That is answer choice, let's see, B. Now, when you look at answer choice B, what you'll see is that the negative is right here, not down here, but that's fine, okay, because when the negative is sort of next to the fraction line, all that means is that it could either go up to the top or it could go down below, but it can't go both. Now we have it down below, and that's fine. And answer choice B matches our answer. It's helpful to remember that the average formula is the sum of values all over the number of values. And that is the formula for the average, and they tell us that Pete has an average score of exactly X points. So they actually give you the average X. Okay, so notice how we're putting X here where the average would be. And apparently it's 4 tests. So we know that this number is going to be 4. And how many points higher must Pete score on the 5th test? So we're going to say that this is the sum of the first 4 tests, okay? So this is the information we have so far. Now, one thing we know for sure, based off of this information, even before I sort of read the rest of the problem or focus on the rest of the problem, is that the sum of the first 4 can be rightfully said to be 4x. Okay, and you would get that by multiplying both sides by 4. Okay, so, I'll even kind of write that out. If you multiply that by 4, you multiply that by 4, it would result in a cancellation. And therefore, we know that the sum of the first 4 is equal to 4x. It's often the case that with average problems on the ACT, they're going to give you initial information you need to plug into this formula, and then you have to do, I actually call that the crucial move for averages, where you have to multiply both sides by this number, to at least figure out what the sum of the first batch of stuff is, okay? Now, we keep that in mind because now they're talking about a fifth test, and we will hone in on the exact question. The exact question is, how many points higher than X must he score on the fifth test? Now, first of all, let's just kind of get clear that we're going to call the fifth test y because it is an unknown quantity. Fifth test. Okay, so it's an unknown quantity, and we want to come up with a variable that's different than x because x is already being used. So let's also get clear that we want to find out, y is how many points higher than x. In other words, the fifth test, the score of the fifth test, is how many points higher than x. That's what the problem is asking. So you want to sort of look into the future and just imagine that you're able to create a situation where it's like y equals x plus something. Because isn't that what the question is asking? They want to say, okay, the score of the fifth test is higher than x, but how many points higher than x? X plus what equals y? So I think that's really helpful for this problem, is to just see what the end goal is. Our end goal is to essentially solve for y in terms of x. So we're going to need an equation that features both y and x. And that's where this average equation, once again, comes in. Now the target average is x plus 2, apparently. We want that to be the new average. And we're now dealing with 5 tests. And up here is going to be the sum of all 5 tests. Now, the sum of the first 4 tests we already know is 4x. So we will be writing 4x right there because that's the sum of the first 4. We've already decided that y is a good variable for the 5th test. At that point, we can begin the process of solving for y in terms of x, and we could do so by multiplying both sides by that denominator of 5. Therefore, the 5's cancel, and that leaves us with 4x plus y equals, let's just kind of get this over with immediately with the distribution. This 5 is going to distribute both to the x and the 2, so that's going to become 5x plus 10. At that point, we can subtract 4x from both sides, and what do you know? You now have y by itself equals x plus 10. So as I highlighted before, this is what we want. We want it to be y equals x plus what number? Because we want to find out, what is this number? How many points higher than x does our 5th test score need to be? Well, we just found out. We just found out that in order to satisfy an average of x plus 2, which is, what the problem suggested, in order to satisfy this new average of x plus 2, the score of y needs to be 10 points higher than x, and that is y. The answer is K for that one. Your best bet with 51 is to just draw like generic lines that intersect. We'll call this L, we'll call this M. And it forms angles A, B, C, and D. Now, we're not going to worry about whether or not this diagram is drawn to scale, okay? We're just going to proceed accordingly. So the measure of B apparently is 3.5 times the measure of A. So B equals 3.5 A. Some of you could already see where this is going. It will feature supplementary angles, linear pair, all that stuff. Which of the following values is closest to the measure of A? All right, well, we already have enough information to figure that out. I mean, truth of the matter is that we know that this angle here plus whatever this angle is, well, they're going to equal 180. We also know that this is A, and we know that this is 3.5A. And we'll set that equal to 180. So we have A plus 3.5A equals 180. Combining like terms gives us 4.5A equals 180. And dividing both sides by 4.5 would give us 40. So that's the answer, D. Pretty straightforward. Notice how you did not need to really bother with angle D or angle C. And also notice how it was, pretty helpful to draw the diagram and, go clockwise around it. That way we can clearly see A and B are a linear pair. Okay, so problem 52 presents to you a sequence that can definitely be confusing. However, I would like to offer a relatively organized way to go about this stuff, and that would be to have n up top, to have the sort of the sequence, the definition of the sequence below. So in this case, it's 2 times s sub n minus 1 plus n plus 1. That's below. And then down here, we're going to have the actual number in the sequence. So giving us a few columns at least to work with. I mean, ultimately what we're interested in is s sub 4. So this will be 1, 2, 3, 4. It's going to be the first 4 terms in the sequence, okay? And therefore this would be s sub 1, this would be s sub 2, this would be s sub 3, and this would be s sub 4. And this is the one that we're really interested in, okay? This n is down below, and the n's are up here, so s sub 4. This really stands for the first term in the sequence, the second term in the sequence, the third term in the sequence, the fourth term in the sequence, and hypothetically it could go on forever. So with regards to what belongs in here, well, apparently s sub 1 is 3. So since there's this recursive situation, they're going to have to give us a starting point, which is 3. And this is sort of irrelevant because we don't need the structure to figure out what the first term in the sequence is, because we already know what it is because they gave it to us. However, we will need that structure in the future. So for example, in the column where n equals 2, the current n equals 2, this structure would have it be s, or 2 times rather, s sub 2 minus 1, 2 minus 1, plus 2 plus 1. So you can see how it's going to be n minus 1. It's 2 minus 1 because the current n is 2. But what you'll see is that that's just code for the number that came before. And what I mean by that is, on this next line, you can clearly see that it's 2 times s sub 1 plus, we'll just say 3 because we know that it's that, because it's 2 plus 1 over here is 3. So in other words, it's going to be 2 times s sub 1, which is the number that came before. So when you see this s sub 2 minus 1 or s sub n minus 1, that's code for 2 times the number that came before. So ultimately, this becomes 2 times 3 plus 3. And that is 6 plus 3, which is 9. Now, I know that that was quite a ride. There's a lot going on in there. There's the n minus 1 here, and then there's the current n here. Notice how the current n was 2, and I put that right there. And then, as though that's not bad enough, they stick a plus 1 at the end. So we have to go plus 1. So let's try that again, only we're going to kind of cut to the chase. Now that we know that s sub n minus 1 is code for the prior number in the sequence, it's going to be a little bit easier. So we're just going to kind of cut to the chase this time, where it's going to be 2 times 9, because that's the prior number in the sequence, plus the current n, which is 3, plus 1. Current n is 3 because it's right there. It's right here. And then the question is, okay, well, what is that? Well, that's going to be 18 plus 4, which is 22. So we're clearly getting closer to s sub 4, which is what we want. Once again, we're going to cut to the chase. It's going to be 2 times the number that came before, plus the current n, which is 4, once again, plus 1. So that's going to be 44 plus 5. And that, of course, is 49, which is the answer, J. So in case you're confused, just know that a sequence is just a sequence of numbers that follow a pattern. Sometimes the pattern is given in this sort of structured formula here, and this will help you know what comes next, depending on what number in the sequence you are. And the number in the sequence that you are is n. So this is the first number in the sequence. 9 is the second number in the sequence. 22 is the third number in the sequence. 49 is the fourth number in the sequence. And you put these numbers into that, and it churns out almost like a snack machine. You put the number in, and the output ends up being the actual number in the sequence. All right, so you might want to YouTube sequences, not series, but sequences for these kinds of problems, and just give yourself a little practice. I think 53 is a great problem to use your own numbers. Once again, if you have variables in the question and also variables in the answer choices, that could be a sign to use your own numbers. So apparently, a is an integer less than -1, so let's make a -10. And all we have to do really is research, okay, what's the absolute value of a, what's -a squared, what's -1 over a. So the absolute value of a is the absolute value of -10, and that turns out to be 10. -a squared is -10 squared. Notice how I put the 10 in parentheses though, because this exponent of 2 only gets applied to 10. It only gets applied to a, not the negative that's in front. That -1 that's secretly hanging out in front, that is unaffected by the exponent of 2, so we don't want to square that. So this just becomes -10 squared, which is -100. And then we have -1 over a, so that's going to be -1 over -10. So that's a negative fraction. And in reality, it's really a -1 times a negative fraction. And that's going to be a positive fraction. So it's going to be 1 over 10. Now, to be clear, this was the absolute value of a. This one was -a squared. This one was -1 over a. And if we want to know which one came first, well, if we're going to list it from smallest to greatest or from least to greatest, then it would be, this is definitely number 1 in least to greatest, this is number 2 in least to greatest, and this is number 3. So that's the proper order. So in other words, we're looking at, what is it, -a squared, right? -a squared is less than -1 over a, which is less than the absolute value of a. So that is E. So yeah, moral of the story, you might want to plug in your own numbers just to bring this problem down to earth. So the expected value is the average score you would get if average score per draw that you would get if you played this game forever. And the truth is there are 10 cards. Okay, 10 cards. Now, in reality, do you have to draw this when you're doing the ACT? No, but you could at least see it in your mind. And one card has 1 point on it, two cards have 2 points, three cards have 3 points, and then four cards have 4 points on them. So anytime you draw one of these, you get 4 points, and then you put it back face down. And then maybe you draw this one and you get 2 points, and then you put it back face down. So expected value rather, would be the average score you get every time you draw a card. Now, often you're not going to get a whole number average score for the expected value. It might end up being like 3 point something or whatever. And again, it's just a way of saying, on average, how many points will you get per draw if you played this game forever. So the way to do it is to set up a table. That's probably the most popular and easiest way to go about it. And the table should represent the points you could score per draw, the probability of getting that, and then you could say the product. Now, the product is essentially to multiply these two, and that's going to come into play throughout the process. And at the end of the day, there is a 4-step process, really, for expected value. And the first process is to list this column. The second process is to list this column. The third part of the process, is to list this. And then the fourth part would be to add everything in this column. Now, the points you could score are either 1 point per draw, 2 points per draw, 3 points per draw, or 4 points per draw. So those are the points you could score. Now, what's the probability of pulling a card with 1 point? Well, that would be 1 over 10. What's the probability of pulling a card with 2 points? That would be 2 over 10, and this would be 3 over 10, and this would be 4 over 10. Now, I'm going to keep this denominator of 10 for now. I actually kind of like that we have the same denominator here. Could I reduce this to 2 over 5? Yes. Could I reduce this to 1 over 5? Yes. But I have a feeling that keeping it in the same denominator is going to be useful, at least in the beginning. All right. If we have to reduce something at the end, we're going to do that. Now we're looking for the product where I'm going to multiply 1 times 1, 10, and that ends up being, of course, just 1 over 10. Then we multiply 2 times 2 tenths. Well, that's going to be 4 tenths. 3 times 3 tenths is 9 tenths. 4 times 4 tenths is 16 tenths. Once again, I am keeping that denominator of 10 because there is that fourth step where I have to add everything in this column. And that is the answer, actually. That's going to be the answer. So when it comes to expected value, you do have to remember these 4 steps. You have to remember this table and these 4 steps. Now, clearly, the denominator is going to be 10. We have 1 plus 4, which is 5, plus 9, which is 14, plus 16, which is 30. And 30 divided by 10 happens to be 3. So it turned out that it is a nice number, a nice whole number. It won't always be that way necessarily, so don't get attached to that and don't freak out if you end up with a decimal. So what this says is with this situation, you will get 3 points per draw on average. 3 points per draw on average. So, yeah, that is J. I would say for problem 55, make up your own numbers. Um, when you see variables in the problem and variables in the answer choices, you might want to make up your own numbers and just kind of take it from there. Now, obviously, you have to obey the parameters that they set for you. And the parameters in this case are the fact that x is less than y, which is less than z, and also x, y, and z are consecutive odd integers. Now, odd, I think everyone knows what odd is. Consecutive means, they follow each other if you were to like list the odd numbers. So let's make let's make it a little bit higher, 7. We'll make this 9, and we're going to make this 11. And they're taking interest in the sum of these. So let's actually go ahead and just find the sum. So that's going to be 7 plus 11, which is 18, plus 9, which is 27. So the question is, if x equals 7 and y equals 9 and z equals 11, which one of the answer choices would give us 27? Well, let's check it out. Answer choice A says 3z. Well, 3 times z is 3 times 11, and that's 33, so that's gone. Answer choice B says 3y. Well, y is 9, and 3 times y, 3 times 9 is 27. So answer choice B works. Now, we do want to be careful. Because we made up, our own numbers, let's just be careful and check the other ones. 3 times x, answer choice C, 3x, that's clearly not going to work. That's 21. Answer choice D, 3x plus 2. Okay, 21 plus 2 is 23. That clearly does not work. And answer choice E clearly does not work because we want the sum of x plus y plus z, whereas answer choice E is giving us the sum divided by 3. Right? So we don't want to divide it by 3. We just want the sum. So we will preserve the happy face. B is the answer. Problem 56 is pretty interesting. It's always a little bit more challenging when one of the answer choices is cannot be determined, right? It can sort of inspire a feeling of insecurity, I suppose, but at the end of the day, just stick with the definitions of median and mean and just kind of take it from there. So, for example, we know that the mean of the set of 5 numbers, 42, 3, 11, 27, and x, well, that's 24. So that was only gotten as a result of adding 42 plus 3 plus 11 plus 27 plus x and dividing by 5. Now these, when you add them together, 42 plus 3 is 45, and 45 plus 11 is 56, and 56 plus 27 is 83. So 83 plus x all over 5 equals 24. We actually have enough information here clearly to find out what x is. And what we can do is we can multiply both sides by 5 at this point. And as a result of that, we cancel this one. And 5 times 24 is 120. So we end up with 120 equals 83 plus x. Obviously, subtracting 83 for both sides would give us 37. So it's official that we have x. And that's kind of nice to know because the problem asks us what is x minus y. So now the question is there a way to find y? Is there a way to find y? And it's a good question. So let's investigate the situation. We have a set of numbers called 53, 8, 29, and y, and that's 4 numbers, and apparently the median is 38. Apparently the median is 38. Well, it's tough to know exactly how to list the numbers because we don't know where y is, right? We don't know what y is. We don't know where y is. I mean, I suppose we can get somewhere by at least taking the 3 numbers that we do know and listing them in order, because when you're finding the median, you're going to want to do that. Now, it's the case that y is either here, 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 or here. And let's imagine the first scenario where y is here, and we'll just ask ourselves, is that possible? Well, if that was the case, then since the median is 38, then these 2 numbers, the average of these 2 numbers, would be 38, but it's not 38, right? 8 plus 29 is 37, and 37 divided by 2 is clearly not 38. So what I would actually like to do is then investigate, is it possible that y is over here? And if that's the case, then these would be the 2 middle numbers, and the average of these 2 numbers would be 38. Now I'm seeing that it wouldn't be because I'm actually just paying attention to the units digits. 9 plus 3 is 12. That would give us a units digit of 2. And then when you divide that units digit by 2, it becomes 1, whereas 38 has a units digit of 8. So that's really just a fancy way of quickly seeing that the average of these 2 numbers does not equal 38. So therefore, y cannot be on this end. We've already discovered that y can't be on this end. So what that means is that y is either here or here. Now, it might seem like it should matter which one of these 2 it is. We've already eliminated the possibility that y is on the outside. And we know it's here, and it might seem like it's necessary to know where it is. But it actually doesn't matter right now, because all that matters is that we know that the median will be found by averaging 29 and y. Because let's say the y was placed here, well, these would be the 2 middle numbers, and we'd have to find the average of y and 29. Let's say that y was placed here. Well, we'd still have to recognize that the median of 38 is produced by averaging 29 and y. So regardless of whether or not y is there or there, it really doesn't matter. The bottom line is we officially have enough information to solve for y. 29 plus y, without question, divided by 2 is going to be 38. Okay, so that's just a fact, and the way that we know that is because there were 4 places where y could be. It could be here, 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 or here. We eliminated the possibility that y was here. We eliminated the possibility that y was here, because when y is here and when y is here, it doesn't produce the proper median, which is 38. So y has to be here or here, and therefore the median is produced by finding the average of 29 plus y, 29 and y. So we could now multiply both sides by 2, and that would most definitely cancel these. We end up with 29 plus y equals 76. Subtracting 29 from both sides would give us 47. So y is 47. Y is 47. We totally figured it out. And at the end of the day, they want x minus y. So that will be 37 minus 47. And that most definitely equals negative 10. And that is G. Okay, so for problem 57, the area of the rectangle is 144. And we also know that the length has to be greater than the width. We'll call this the width, and we'll call this the length, just to give ourselves a visual. And at this point, they're asking, which of the following perimeters in inches is not possible for such a rectangle with this area? Seeing as how the length is greater than the width, and the length and width are whole numbers of inches. So I would recommend making columns, and the columns would be length and width, and we want to make sure that the numbers in this column are always bigger, greater than the numbers in the width column, because the length is supposed to be greater than the width. And as many of you would probably guess, we're really just looking at factors of 144. Okay, and at the end of the day, what do we want? We want the, which are the following perimeters, right? So we're looking for perimeters. We want to keep that in mind. So the final answer will be composed of 2 times whatever the length is, plus 2 times whatever the width is. So what we're going to do is we're going to investigate all the possible lengths that could be, and all the possible widths that could be. And we're going to start with a high number for the length because we want the lengths to be greater than the widths. And I think most of us can see that these columns are going to feature the factors of 144. Now I will say 144 does have quite a few factors. And you might be wondering, well, how can I best figure out what they are? Well, you might want to set up this sort of rainbow list where we know that 1 times 144 gives us 144. We know that 2 times something, because 144 is even, and that would be 2 times 72. 3 goes into it, and I'll explain how I know that in a moment. Let's just do this rainbow. Now, you don't have to draw the rainbows yourself, but I'm just showing how it works. So 3 times something goes into 144. You might be wondering, how did I know that? Well, I knew that because I added these digits in 144. 1 plus 4 is 5, and 5 plus 4 is 9. And that sum, 9, is itself divisible by 3. Whenever that's the case, the actual number is divisible by 3. You could test that out. Try it with 81. Try it with 27. Try it with, any number divisible by 3. You will find that when you add the digits, if that sum is divisible by 3, then the entire number is divisible by 3. So I know that 3 goes into it. So let's see, you could use a calculator, of course, but it looks like it's going to be 3 times 40 something. 48? Yeah, 3 times 48. So that's that one. And then does 4 go into it? Well, 4 goes into stuff when the last 2 digits are divisible by 4. So the question is 44 divisible by 4? And the answer is yes. 44 is divisible by 4. So 4 definitely goes into it. And then the question is 4 times what would give us 144? Obviously, you could use your calculator, but I'm going to say it's definitely 336, looks like. 5 does not go into it. Does 6 go into it? Well, 6 goes into it if both 2 and 3 go into it, and both 2 and 3 do go into it. So 6 goes into 144. Obviously, the question is 6 times what gives you 144? Well, that would be 6 times, let's see, 2, 24. 6 times 24. 7 does not go into 144. You could double check that in the calculator if need be. 8 does go into it. 8 goes into it. 8 times 1, 8. 8 times 18, actually. 8 times 18. And 9 does not go into it, 10 doesn't, 11 doesn't, but of course 12 times 12 would give you 144. So if we were simply listing the factors, we would just leave the 12 there because it's 12 times itself. But I think it's worth noting that, 12 times 12, right? If we were doing length and width, it would be 12 times 12 here. Now, we're not going to write 12 times 12 here, though, because the length has to be greater than the width, so we know that we don't need to do that anyway. We want the larger numbers to be here. So 144 got paired with 1, 72 got paired with 2, 48 was paired with 3. Looks like 36 was paired with 4. What else do we have? We have 24 was paired with 6. And finally, we have 18 was paired with 8. So these are the possible lengths and widths if we have the parameter that says the length has to be greater than the width. So I'm actually going to get rid of all this, make some room, and let's see here. So the perimeter is 2L plus 2W. I'm kind of seeing that I'm not going to want to do 2 times the length plus 2 times the width and, all that. I'm not going to want to do that because that's going to be tedious. It's going to lead to large numbers. But I think it would be helpful if we're going to sort of consider what the perimeters might be here. It would be helpful to conceptualize the perimeter as 2 times length plus width. Okay. And then we could just kind of expand upon this chart here. We could do length plus width, and then we could say, okay, 2 times length plus width. And it's really this column here that would give us each perimeter. So length plus width, and so length plus width here would be 145. 145 times 2 is 290. Length plus width here is 74. That times 2 would give us 148. So again, these are all the perimeters actually, because perimeter is equal to 2 times length plus width. Length plus width here is 51. 51 times 2 is 102. We have 40 here. 80 would be the perimeter. We have 30 here. 60 would be the perimeter. We have 26 here, and 52 would be the perimeter. So looks like 148 is accounted for in the answer choices. 102 is accounted for in the answer choices. 80 is accounted for. Looks like 60 is accounted for, but then answer choice A says 48, and 48 is nowhere to be found. This is an exhaustive list of all the possible perimeters that this rectangle could have given the parameters. Okay, this is actually all the possible perimeters, and 48, it's not on the list. So that's what they want to know. They're like, which answer choice is not possible as a perimeter? And that is most definitely answer choice A for all of these reasons. Funny enough, problem number 58, which obviously pertains to circles, also pertains to right triangles, or at least it could pertain to similar right triangles. So you can imagine you have two right triangles here, and let's say you know for a fact these angles are the same. And let's also say you know for a fact that the hypotenuses are the same. Well, you would know for sure that these two right triangles are congruent to each other. And the way that you would know that is through angle, angle, side. Angle, angle, side. And that is congruence criteria. Now, what that tells us is that all of the different parts of these two right triangles are congruent. So, for example, this has to be congruent to that. Okay, this leg has to be congruent to that leg. Now, it's also the case these legs are the same, but I really want to focus more on these two red ones, okay? Because this insight is going to become useful in the problem. If you have two right triangles such that there's a straight line across and a straight line diagonally through, and we know for sure that the hypotenuses are the same, and we know for sure these angles are the same, that's a little bit more obvious. Then by angle, angle, side, the two right triangles happen to be congruent, which means all the parts are congruent, including these legs. Okay, so if you see two right triangles that are like this, these legs are congruent. Now, believe it or not, that is going to come into play somewhat here. And before we get into it, let's be clear. We know the equation of a circle. The equation of a circle is x minus h squared plus y minus k squared equals r squared, where hk is the center and r, not r squared, r is the radius. Now, our circle is most definitely this. What is it? X minus 7 squared plus y minus 8 squared equals 10. So that means the center is 7, 8, and the radius, now this part you want to be careful. Radius is not 10. I know this says 10, but remember this 10 corresponds with r squared, not r. So the radius is the square root of 10. Now you do need to remember that for sure. So, great. Great. Then we could get rid of this because I think we know what problem we're on. Imagine you are graphing this. And if you graph it, well, 7 seems to be an interesting and important number. 8 is an important number because that is where the center is. Now, let's also get clear on a couple critical values because the radius is radical 10, and that's really like 3 point something. That's like just over 3. Okay, so if we're going to draw this circle, at least even like a rudimentary rough draft version, I'm going to strongly suggest going 3 down and giving us 5 here, 3 up, which would give us 11 here, 3 to the left, which would be 4, and 3 to the right, which would be 10. And when drawing the circle that has a center right there, we're going to want the outside edge of the circle to be just underneath this 5. So I'm going to put it there. We're going to want this outside edge of the circle to be just above that 11 because, again, the radius is 3 point something. And we're going to want this one to be just to the left of that 4. So we'll put a little marker there. And we're going to want this one to be just to the right of that 10. Okay. Now, do you have to draw all of this and label everything that I'm labeling? No, you don't. But you at least need to have this, an understanding of this in your head, at least. Okay. So according to the problem, they have some endpoint of a diameter, and that endpoint has a y-coordinate of 11. So that means that the endpoint of the diameter is either here with a y-coordinate of 11, or it's here with a y-coordinate of 11. Turns out it doesn't matter which one you choose because we're only interested in the y-coordinate of the other endpoint. So if you have an endpoint here, well, the y-coordinate of the other endpoint would be down here somewhere. And if you have an endpoint here, well, the y-coordinate of the other endpoint would be down here somewhere, and those y-coordinates would be the same. Now, I know it seems like there's a 5 here, so that should be the answer. Now, that might be the answer as far as the y-coordinate of the other endpoint, but we need to prove that. So let's just choose our placement of the endpoint, the first endpoint of the diameter. Now I'm going to put it here, and I could have put it in the other place, but I'm going to put it here. And notice how it, corresponds with this 11 here, because the coordinates of this endpoint, I'll call it x1, comma 11. Now, you might be wondering, well, what's the x? Well, actually, we could find out what this x is, but it turns out that the x is not relevant to the problem because what we're only interested in is when you draw this diameter across, what will the y-coordinate of this one be? So I'm going to label this x2, comma, question mark. And that's what we're trying to find out. We're trying to find out what is this y-coordinate there. Now, the way that I would go about this is to imagine that we have the this a horizontal line kind of cutting through the center at the y value of 8. Okay, so we have this horizontal line cutting through. And imagine we drew right triangles like that. Okay, so this goes straight up to that point, and this goes straight down to that point. Well, isn't it the case that, first of all, these angles would be vertical in that case, meaning these angles would be congruent. So these angles are congruent, and it's also the case that the hypotenuses are congruent as well, because this is a radius and this is a radius, and the radius is equal. So therefore we know that this leg has to be congruent to that leg because the triangles are congruent for the previously mentioned reasons. At the beginning of this problem, I showed you that these right triangles have to be congruent if the hypotenuses are congruent and if these two angles are congruent because of angle, angle, side. The triangles themselves are congruent, which means the corresponding parts are congruent, which means this has to be the same length as that. Now we know what this length is. It goes from 8, the level of 8 all the way up to 11. It goes from 8 to 11. So that length is 3. And therefore, if that's 3, we have to understand that that's 3. That's got to be 3. So this goes down 3 from 8, which means that this y-coordinate is 5. Okay? It's 5. Now, I know that it looks like 5 because I had labeled 5 before, but now we actually proved it. This could have been, a little bit up here above 5. It could have been down below 5. We just proved that it is indeed 5. So that's the answer. The y-coordinate of the other endpoint, this was the first endpoint, the y-coordinate of the other endpoint is 5. So that is J. Okay, so 59 is what I would call a change in volume problem. Okay, these pop up every now and then on the ACT. And let's take a look here. So the plans for a diving pool call for a rectangular prism that has a length of 30, width of 25, and depth of 5 meters. Well, volume would therefore be First of all, it's length times width times height. I could draw it here for you. Maybe that's helpful. The length is apparently 30. The height is, or the depth really is 5. And then we have 25 here. So that would be, 30 times the width, which is 25, times the height, also known as depth, which is 5. Now, here's the thing. We could totally solve that and find out what the volume is, But there's a faster way. Here's the faster way. We'll call this volume 1. Volume 2 is after the transformation. Volume 2 is what you get when you take the original dimensions and you mess with them. Okay, so I'm actually going to write the original dimensions here. We're going to tweak them a little bit. And what are we going to do to them? Well, let's see. The length, price will change by increasing both the length and width by 10%. So that's going to be 1.1 times 30, because increasing by 10% means it's 1 times 30 plus 10% of 30. We're also going to multiply the other thing by 1.1. What is it, 25, the width, by 10%. And that's it. So what we could do is then rearrange all of this stuff. So it's really like 1.1 times 1.1, and that's going to be times 30 times 25 times 5. And 1.1 times 1.1 is 1.21. So it's really 1.21 times 30 times 25 times 5. Now, let's be clear. This was the original volume, right? That was the original volume. I'll even write that. Original volume. The red part. So volume 2 basically takes the original volume and multiplies it times 1.21. And it's really this 0.21 part that represents the percent increase on this, because it's really 1 times that plus 0.21 times that. So in other words, it's 1 times this plus 21% of this. So it's a 21% increase, which is D. Now, some of you might not like what I just did, because what I did is fancy, kind of like a fancy way of going about it. So if you're wondering if you could go about it in a more straightforward way, yes, and here's how you would go about it in a straightforward way. You would soon discover that volume 1, after multiplying all this stuff, would be 30 times 5 times 25, and that is 30 times 5 times 25. That is 3750. And then if you want, you could, after having calculated the original volume, you could then go ahead and go on a mission and calculate this volume, because they tell you what to do. They're like, oh, this was increased by 10%. How do you increase 30 by 10%? You multiply 30 by 1.1. So that part's huge. You need to understand that, increasing a number by percentage. Because let's think about it. If I want to increase 30 by 10%, what's going to be 30, plus 10% of 30. That's how you increase 30 by 10%. And really, there's this sort of invisible 1 in front of there. And these are the coefficients. And these are like terms, right? Because they have 30. So that turns into 1.1 times 30. Okay? That's how you increase 30 by 10% of itself. Turns into 1.1 times 30. So You could just multiply 30 times 1.1. You can multiply 25 times 1.1 because that's the width, I believe, and this is the depth. The depth is unchanged. And if you were to do that, it would become 4, 5, 3, 7.5. And then what you're going to do is you're going to ask yourself, okay, well, what percent increase was that? Well, one way of going about it, if you want the percent increase or decrease, you take the new amount minus the old amount all over the old amount, and then just multiply that times 100, and that would give you the percent increase or decrease. Okay, so that's a formula that if you prefer the more straightforward approach that I am describing, you could use that formula once you found the first volume and then the second volume. And let's do it. So it's going to be 4, 5, 3, 7.5 minus 3, 7, 5, 0, all over the original amount, the old amount, which is 3, 7, 5, 0. And we're going to multiply that by 100. And what that will give us is the literal percent increase. So that's actually going to give us literally 21. So you don't have to mess with any decimals or anything like that. If you do this in your calculator, that's going to turn out to be 21. Now, that's the answer. And by the way, the fact that 21 was positive means it's a percent increase. If the number on this side ends up being negative, well, that's going to be a percent decrease. All right, in fact, I should be writing decrease here. Okay. So that would be the more sort of straightforward way of going about it. But I will say that's actually more tedious. That did kind of take long. Whereas if you just go about it this way, where you don't bother multiplying them, you keep them separated, you realize that for the transformation, you're going to have to increase 30 by 10%. You're going to have to increase 25 by 10%. And then you just shuffle the parts around and realize, oh, this is the original volume. Clearly, it's going to be 1.21 times the original volume. And that is a 21% increase. So one way or the other, the answer is D. Okay, so problem number 60 incorporates many, I would say, relatively advanced concepts, actually. So let's begin by getting clear on the quadratic formula, which is this. Let's just get a little reminder of that. Now, when do you use the quadratic formula? You use the quadratic formula when you have a quadratic equation that maybe is not factorable and therefore not easy to solve using factoring. In fact, you can't solve it using factoring. So what you do have to do is you have to recognize that 3 would be the A in this case, 4 would be the B, the coefficient of the X term, and then the constant would be the C. And you can actually solve for X literally by plugging 3 in for A, 4 in for B, and -7 in this case, -7 in for C. And then you just simplify this thing right here as much as you can. Couple things to note. There is this plus minus situation. So it's often the case that this will yield two solutions, a positive, negative b plus blah, blah, blah over 2a, and negative b minus blah, blah, blah over 2a. Now, whether or not you have two solutions or any of that stuff depends on the discriminant. Now, the discriminant is just this section here, and we're going to talk about that a little bit because it does come into play with this problem. So if it's the case that b squared minus 4ac equals 0, then there's one real solution. One real solution. Now, why is that true? Well, if this was 0, then it would just be negative b over 2a. And that would be one single real solution. Now, when we use the word real, we are talking about it in contrast to an imaginary solution or a complex number. A complex number is a number that, at least in the context of this problem, it's a number that features an imaginary part. Okay, and we're going to get to that in a moment. But if it doesn't feature an imaginary part, then it's a real number. So when it's the case that b squared minus 4ac is positive, then we say there are two real solutions. So that sort of makes sense as well, because if you end up with a positive number under this radical, well, it might be an ugly, crazy, irrational number, but at least it will result in a real number because it will be the square root of some positive number, which has a value somewhere on the number line, and it would be two real solutions because it would be negative b plus that over 2a, and then it would also be negative b minus that over 2a. So whenever the discriminant is positive, you have two real solutions. Now that leads us to the last scenario where the discriminant is negative. Now when that's the case, there are two, you could say either imaginary or we could say complex number solutions. And what is implied in the context, we'll say solutions. What is implied in the context here is that they are not real because there's an imaginary part. Now, I don't want to get into imaginary numbers too much, but just know that if the discriminant is negative, that means that there's a negative number underneath this square root symbol. And the truth is you cannot take the square root of a negative number in the real world. That leads to an imaginary number, okay? So in math, anytime you take a square root of a negative number, it's going to be an imaginary number, okay? Because it's impossible in the so-called real world, but in certain situations, it's temporarily useful to at least imagine that you could, okay? There's certain, maybe even engineering situations where it's helpful to at least imagine that you could take the square root of a negative number. But at the end of the day, even if that's mind-bending and annoying to think about, just remember these three things, these three scenarios. Okay, so that's one thing that will be useful to remember for this particular problem. Now, another thing that's useful is synthetic division. Synthetic division. Now, you could always YouTube synthetic division, figure out how it works exactly. I'm going to actually dive into this problem right now and use synthetic division right away to get close to the answer. For those of you unaware of synthetic division, just do the best you can to follow what I'm saying. For those of you aware of synthetic division, of course, follow along as well. And for some of you, it might be a matter of just shaking the rust off, okay, and getting used to it again, seeing how it works. So they give us this equation called 4x cubed minus 2x squared plus x plus 7 equals 0. And they're kind enough to say, oh, by the way, x equals -1 is a solution. Okay, x equals -1 is a solution. So then they ask, which of the following describes the other two solutions? Well, let's get closer to understanding what the other two solutions might be by using synthetic division. Now, at the gate, And not really seeing an opportunity to factor this at all. Unfortunately, you can't even factor it by grouping. So we are going to break out synthetic division. Now, if it's the case that one of the solutions is -1, that means that this thing is divisible by x plus 1. X plus 1 is a factor of this. And what that means is we can use synthetic division to kind of figure out um, how this could be factored, okay? Now, what you could do is you could take what you already know to be a solution and put it here in preparation for synthetic division. Now, across this row, we're going to write the coefficients of each of these terms. We have 4, we have -2, we have 1, we have 7. Now, we already know that -1 is going to work, okay? So we could just set this up. Now, it's the case that we do have this beautiful descending exponent scenario, which is what we want. Had there been no x term, we still would have had to represent the x term with a 0 in front of it. Turns out there is an x term represented here, and there's a 1 in front of it. But you would need the 0 for a placeholder. So we have 4, we have -2, we have 1, and 7. Now, once again, if there was no x term, if it was really just 4x cubed minus 2x squared plus 7, we would put a 0 here to represent the invisible x term, okay? We don't have to do that for this problem, fortunately. Right away, you're going to want to drop this 4 down. That's the first move. And then, once you drop it down, you then multiply -1 times 4, and that gives you -4. You then add these, and that gives you -6. You then multiply -1 times -6, and that gives you a +6. You then add these, and that gives you a 7. You then multiply -1 times that +7, and you get a -7. Now you should, if all goes well, get a 0 here. That's how you know actually you're on the right track, if you get a 0 here. Now, what we have learned is that this original equation can indeed be factored, but it's not obvious how to factor it. But what it can be factored into so far is x plus 1 times something else, and that equals 0. Now we're going to get to that something else in a moment. But let's talk about this x plus 1. How do I know that x plus 1 is one of the factors? Well, I know that because one of the solutions is x equals -1. You get that solution by considering this binomial here. Most of you watching are used to factoring stuff and realizing that, oh, if x plus 1 is one of the factors, well, x equals -1 as one of the solutions. Well, they gave us that. So therefore, we know that this binomial is in there somewhere. The question is, what's this other big factor? Well, the other big factor we just found out. We just found that out by doing this synthetic division. The other factor is 4, not x cubed, because it started x cubed. But we get the 4 here. It's 4x squared. You drop the exponent down 1, minus 6x minus 7. Or plus 7 rather, okay, because it's a +7. Where did I get the coefficients for this? I got them from the synthetic division. Notice how this is 0. This is where the remainder would be. It should be a remainder of 0, okay? If x equals -1 is a solution, -1 is a solution. So we already know about the solution. What the problem is asking us about are the other solutions. Well, the other solutions will be found by analyzing this part. And really the first thing you should be asking yourself is, well, all right, well, is this part factorable? Well, it turns out you cannot factor this part. You cannot factor this part. And how do I know that? Well, I know that because 4 times 7 is +28, and there are no two numbers that multiply to 28 but add to -6. It's not going to happen. There are no two numbers that multiply to 28 but add to -6. So this is not factorable, which means that if we wanted to find the other solutions, we would have to use the quadratic formula. Now, notice how this problem is not asking for the actual solutions. This problem is asking us, in a sense, to simply describe the other two solutions. And that's code for analyze the discriminant. So we're going to analyze the discriminant. Let's be clear. First of all, A in this case is 4, B in this case is -6, and C in this case is +7. Okay, these are the coefficients here. And these are the numbers that we would hypothetically plug into the quadratic formula if we wanted to actually find the solutions themselves. But we're not interested in the actual solutions. We just want to know what kind of solutions do we have. So we're going to now analyze the discriminant. Okay, and that would be obviously b squared minus 4ac, and we're just going to see what happens. Instead of writing b squared minus 4ac, I'm going to write empty parentheses, minus 4 times 2 empty parentheses. This right here is b squared, so that's going to be -6. This is going to be 4. This is going to be 7. So we have -6 squared minus 4 times 7. So that's 36, because it's -6 squared, right? All of -6. -6 times -6 is 36. Now, this is going to be a negative number because it's a negative times a positive, so that's going to be a negative. So I already know I'm going to write minus. But then the question is, what's 4 times 4? Well, that's 16. What's 16 times 7? Well, 16 times 7 is 112. Now, that's clearly going to be negative. Let's just find out what it is, because whatever. That's going to be -76. Okay, so we are dealing with this situation, aren't we? So we know that there are two complex number solutions that are not real. So we already knew one of the solutions was -1. That's given by this parentheses. We use synthetic division to figure out what the other parentheses should be. And then we analyze this in terms of the discriminant to find out what kind of solutions would this produce. Turns out that when you plug in A, B, and C into the discriminant, you get a negative number. So therefore, it is this category, two complex number solutions that are not real. Now, had this been a 0, it would have been obviously one real solution coming from this, right? There would have been one real solution coming from this. Had the discriminant ended up being positive, then it would have been two real solutions coming from this section here. Okay, so that's a lot. If you want further study analyzing the discriminant, you could always YouTube that. When it comes to, okay, one real solution, two real solutions, two complex number solutions that are not real. Sometimes this is referred to as two imaginary solutions, just so you know. Also, you might want to cover synthetic division, okay, and finding the solutions of, cubic polynomials like this, all right? Finding the solutions, factoring these, figuring out what the solutions are, okay? Cubic polynomials. So hopefully that makes sense, but one way or the other, the answer is K.